no one else I'd rather share this with. Nobody knows my imperfections quite as perfectly. You guessed it, it is you that I'm thinking of when we're apart. You're my searchlight when I'm in the dark. It is true. I'd give it all, I'd give my heart. You're my searchlight when I'm in the dark, when I'm in the dark.
Love hard, run fast, be kind, is what Enek would say when he sees what I'm up to right here and now with this printer. Hi everybody, welcome back. And with we, I obviously mean this, where is it? This little plush and me are building a 3D printer, a Voron 0.2 from a Fysetc kit that I got really cheaply off of AliExpress. And yeah, that's basically what's going on here. The printer, you can see right here. This is where we are right now. This is what's going on. This is what we need to finish. We have quite a few things already done. Most of it actually, the mechanicals look pretty decent. We pushed plastic through the hard end last time and it looked quite fine, looked quite consistent. Yeah, so that's going on. Before we get started though, bit of housekeeping. If you see this after the fact, or even if you join somewhere in the middle, feel free to share, like, subscribe. Let me know how I'm doing in the comments. I'm always interested. And let me set something up here. Nice. That's the way it needs to be. We are trying something new today, so I am not quite sure how that is going to go. New in terms of we're multi-streaming. So this is the first time that I'm streaming to Twitch as well as YouTube. And yeah, I'm kind of curious on how that turns out. How that works if we get a few viewers from Twitch as well, because obviously I am interested in bringing this to as many people as possible because it's fun. It's fun, it's something nice, and as I have said and said again, and feel free to check up on that in the reruns on YouTube. I am not technically inclined or mechanically inclined. Let's put it that way. I can do software quite well because I'm a software developer myself, but anything that has to do with mechanical engineering, whenever we talk about stuff like that, whenever I comment on that, please keep in mind I may be talking completely out of my ass there, because I avoided mechanical construction stuff and all this for most of my life, so I'm not actually good at it at all, I think, you know. So anything I do here, you can probably do just as well if you try this. So yeah, maybe pick up a kit yourself or some Legos, because like this is just more complicated Lego, to be honest. Yeah, that's basically it. If you want to catch this stream, the Twitch people can actually check up on this. YouTube sadly doesn't have a schedule as such, but we're trying to be here every Saturday at 7 p.m. Central Europe time. That's 6 p.m. in the UK and 1 p.m. East Coast and 9 a.m. West Coast, I think. So yeah, that's when you can find us here. Even if you missed the stream. I just noticed some scuffing here. Oh well, it's a printer. It's a tool. It doesn't necessarily have to look good. It just needs to do its job. Yeah. that's basically what we're doing right here. If you're watching this past the fact, also note that there are chapters at least in the description if you want to jump around and see what the stream actually contains, and if you want to like just check up on a specific topic, feel free to just use the chapter. That's completely fine. Also, I hope I got the white balance completely figured out and fixed now. Made the chat backgrounds a bit darker, although you're not gonna see those this time. I actually disabled the chats for both Twitch as well as YouTube because there are still a few issues with this setup, with this multi-stream setup. So yeah, let's see how it goes. From the stream monitoring system, I can see that this is looking smooth, but if anyone finds issue with the quality, if anyone finds issue with the sound, with the mixing between voice and music volume, anything at all, let me know. Let me know in the comments, let me know in chat. Say hello in chat if you arrive here. Yeah. Also, there's a Discord, there's a Twitter. You can find those links in the description. And with that, let's go on. Let's go. One warning, since maybe not everybody is on the Discord for Fysetc or by Fysetc and is joining there to see what's going on with this kit. This is actually a bit of an older revision, so this still has the Catalyst 1 board, which means that it has a let's call it a dumb toolhead board. So just a bunch of wires that then directly connect to the components that get controlled by the controller in the back. There is a new version of this kit being sent out that contains the Catalyst 2 board with a more involved toolhead board. And you can basically check whether you have version 1 or version 2, because version 1 only has connectors on one side. Version 2 has the LED connectors, I think, on the other side. Now, there is a caveat to version 2, because there has been an issue that if you plug in the Wi-Fi adapter into the version 2 Catalyst board that is shipped with that new iteration, you may blow up your, I guess, USB controller. It's probably the thing that gets damaged, because that Wi-Fi card may be damaged, maybe faulty. There has been a user reporting that, so just look out. If you want to try it and you have an old USB hub, put that in between so it blows up the hub, not the controller board. Might make a difference of a couple $100. Well, actually about 90-ish between buying a new hub and buying a new board. So yeah, be safe. Also, maybe open a window. Who knows how badly that thing blows up. I only heard it through the grapevine, but there may be something wrong with those adapters. Yeah, otherwise, with cheapish kits like this, be a bit careful of how you build them. It may not be the best idea to build them completely stock. We're going to go into a I don't want to call it a review, but I have a couple of findings that I want to share with you at some point about this kit. And those involve, for example, things like wiring safety, things like steps to look out for, additional steps to take, things that would be better if they changed on this kit. So look out for that. Well, we're actually going to do this on stream, so try to be here for that or watch it in the rerun. But there are definitely things that you should look out for. If you really want to build a printer and it's your first one, this goes along the line of amendments as well. I would suggest you pick up a Voron Trident kit as, instead of this, the Trident specifically, because I think it's the simplest design that came out of the Voron design project. And it is also, I think, and this is my personal opinion, the most versatile in terms of modding and modding capabilities. So yeah, those are the way to go for if you just want to get in the hobby. And here's the amendment. Last time we had a viewer, Dino, cheers to you, who asked me what a good entry-level printer was, and he was asking for the Ender kit specifically. I do not think I would ever go and buy an Ender specifically. Look at the Sovol SV06 instead. That seems to be the better choice. Or the 2 trees, I think. I don't know. Can't remember the name. I think it was 2 trees SK1. The SK1 being more expensive, but is already in a Core XY printer. And if you just want to print, get a P1S, get an AMS. You're going to be just fine with that. Yeah, so those are the amendments. Now let's go on to error correction here, to figuring out what we did wrong last time. And the first thing that I noticed or remembered when I thought about how I built the printer more was that I think I screwed up the fan direction. So that is the first thing we need to fix, because obviously it's no good. It's no good if the controller board, if the drivers aren't cooled properly. That's a recipe for disaster. So let's fix that real quick. That's going to be the first one we need to attempt here. And obviously that's here in the back. And with that, we are off. Let's take this apart real quick. I mean, it's not that bad. It's just a couple of screws. There are designs out there for having these panels be clip-on instead of screw-on. Those are likely a bit more practical, but I decided to build it stock, just for the hell of it. Actually, let's just take this off. So yeah, dealer's choice. I think you're going to be fine with either. And there we go. That's our back panel off. The fan in question is here. The problem with that now is that we screwed in, or that this bracket here is mounted with VHB tape, and because it's mounted with VHB tape, I can't just take it out and turn it around, so I will need to take off the feet as well. So let's get our baby rubber buggy bumpers off. There we go. That's one out. That's the second one. Ooh, I love how these are kept in there. That's nice. That is really nice. Wonder why. And yes, I could have done this with an electric screwdriver, but I don't mind. I don't mind. Let's get in here real quick and let's turn this around. I like that this is working, although obviously there's always room for improvement. So you can see here the fan was mounted with the sticker pointing upwards. That is the air outlet side. The air inlet side is this side. So you want to mount it this way, and then obviously, since it is pressing against our extrusion here, we can simply go and leave that there. So we need to turn it around so the cable comes out the side. Screw that back in. And that as well. And that fixes our fan direction. Now, usually I would have also put a layer of tape over our switch here, but for the moment, for this quick one, I didn't. I would always suggest that you make sure you can turn on your printer while you're working on its electricals. Because especially in this bottom compartment, this is mains voltage, right? This is stuff that kills you. Stuff that kills you. And obviously safety, especially in those situations, is pretty important. There we go. Making sure that's well secured. And that as well, we don't need to pull it too tight. I mean, we want to get it back up again and don't want to damage anything. And by the way, also an amendment from last week, I do realize why the back panel is actually split. And the reason is what we're seeing here. Imagine if that wasn't split. I was kind of posing the theory that it had something to do with previous iterations using different dimensions, and people who were building Vorons already having parts in other sizes. I don't think that's it. I think people were just weary of having to take off the top head here and unscrewing these 4 screws as well, just to get at the electronics. So that's a pretty good decision. Loving that right now, especially because, yeah, you can imagine. Yeah, so good job, Team Voron. And yeah, I realized that pretty fast, but that's what I mean with I may not understand fully because I haven't used the machine fully yet, because I wasn't involved in the design process, and because I have almost no experience with mechanical engineering, mechanical design, stuff like that. I'm amazed at the fact that I can even build these, but that's probably more down to people designing them well than me actually having any particular skill. That doesn't mean I can't do it, and that also means that you can probably do it just as well, if not better. Yeah, a bit of OCD doesn't hurt, to be honest. Just a tiny bit OCD can make all the difference, because the fact is, and this is a pretty cheap printer. I mentioned this before. This was only, quote unquote, 340 bucks, plus a couple of parts that we obviously needed to exchange here because they were not safe, or that I considered not safe, at least, and a couple of things that needed to be improved. But in general, 340 bucks gets you a pretty decent printer build. And this is the important thing. This is a printer for people who want to build printers, who already have a printer, that is working well, because you need to print the parts, but also that they all already experienced where things go, how things work, how to maybe even belt something. Because these 1515 extrusions, they're just impractical as hell. Not supposed to swear. So yeah. Let me drop a quick message here. There we go. And yeah, if anybody joins, or even if you like, I would so love to interact with you guys some more. So if you see this past stream, if you see any of this at any point in time, drop me a comment. I'm sure to respond. Catch a live stream. Anything you want to do to get my attention. Join the Discord. Well, maybe not anything. Maybe keep on your clothes. Sorry, I had to go there. But yeah, okay, so we switched the fan direction. Now the next challenge we had was that, and this is something to look out for in these cheap kits. This is a Chinese kit, and usually you use your own Raspberry Pi with a stock Raspberry Pi image, which is just fine, because then you can be sure that there's nothing wrong with that the open source community has thoroughly tested and checked that. So it'd be good to just take this thing, connect it to your network, and go. Now, this kit specifically does not come with a Raspberry Pi, but with a replacement. And while the replacement itself is just fine and it's going to work great, it is a custom firmware, and that custom firmware is distributed through Fysetc, so a Chinese company. And I am somewhat weary of the privacy practices of Chinese companies, or intellectual property practices as well. So there may be something that's actually mandated by law. I don't know, but it's definitely something to be aware of. So I, for my part, would not want to connect this printer specifically directly to my network, or any other printer that comes with a custom firmware, custom OS. So we need to find a way to access this, because the only way to access it is by network. And we need to find a way to now connect to it without connecting it to our router. So before we actually turn it on, let's grab ourselves the explainer mode, and let's look at what we can do here, or what the idea is of how we want to set this up. And let's go in here a bit, push the printer aside. Well, not sure I like this. Not sure I like this. I'll figure it out. How is that? Okay, sorry if anybody watches this. It looks like the microphone was connected to the virtual machine. Let me see. Okay, that's a bit of a weird problem to have. I'm not sorry when audio cut out. I was babbling along all along, explaining what we did and how we went through all the setup and issues. Just to catch you up here, the idea is to get an isolated bit of network with an isolated DHCP server going, to make sure that this printer doesn't have access to the internet. So we went through a DNS mask DHCP server setup on the Linux virtual machine. We bridged our network, and now we're trying to make it work, which at the moment it isn't. There we go. We're logged in for the moment. Things seem to be working properly. Except for my audio monitoring now getting spasms. So let me grab a USB-C cable real quick. That's going to be difficult. That is going to be a pain in the ass. I mean, it's enough if you guys have audio. I don't necessarily need it. As long as you can hear me and you get a good sense of the music. That's all I need. Okay, so let's go on here. We can see that our lightweight DNS server came back up. These are old logs from the previous time it was run, so that's actually not our printer. We need to turn our printer back on, and now it hopefully gets an address. Let's hope that works. Let's hope that works. Oh. Oh, yes, 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 of course, that's what we still need to do. One hurdle here is, you can see it there, that ETH0, our network interface, doesn't have an IP yet. the way we can give it one, since it needs a static one now, that because it doesn't get one from DHCP itself, because it is the DHCP server. Yeah, we need to give it one. So at the moment we only have loopback here, which means that the ETH0 gets auto-configured, which means that it automatically defaults to DHCP. We want to give it a static IP of 42 dot. Let's give it a, yeah, let's give it a 254, and then we need it. Need it to have a net mask of 255, 255, 255, 0. That's that. Then we can bring it up. Obviously, we need to be root. And now it should have received a network address. Curious why it didn't. Oh, yes. There we go. Now we can see our internet address and our net mask, and it looks like all the things are configured correctly. Nice, nice, nice. Let me check on our music here real quick, because I think that's that's having a bit of trouble. Because I disconnected the headphones. Let me see here. What's going on? It's not going smooth today. It's definitely not going smooth today. Something in the audio system is very much screwed up today. But I came prepared. I came prepared. What we're just gonna do is, oh, we're gonna try reloading this first. Try making it work first. It says an unexpected error occurred when we were trying to load the music. So what we're just gonna do is we are going to go to our fallback. And we're going to play it from there. It's not like we haven't prepared for exactly that. And then we for some reason can't do what I wanted to do. Damn. Okay. We're gonna get there. We're gonna make it work. We are just going to go into studio mode. We're going to modify our scenes here. To have a macOS audio capture. Then we're going to capture VLC. Okay. And we're going to add this to all our base scenes. And as soon as that's done, I'm back with you guys. Well, the zero that you are there, I think. But still, nice to have you. Yeah. And now we should be able to display that. And this is probably way too loud for you, so sorry. Sorry. Because I now need to make this Okay, that we're getting there. So now I can actually connect these directly, which means I can now play the audio on these. I hope that that is somewhat of an acceptable level. And then we're just going to move this aside. And I'm gonna send these to another audio device that isn't actually capable of playing audio right now, because my headphones are not doing what I want them to. All right, okay, so panic averted. Yes, I'm playing with the zoom here a bit, so sorry for that. The one monitor is quite a ways away from me, so I kind of had to. Probably something you want to skip if you're watching this past the fact. There's probably nothing interesting there. Okay, so we got it to work again. We have our virtual machine with an IP address. We can actually, let's make sure to reboot that. Let's make sure we turn our printer off and on again, so we're in a safe state. And then we might actually have an IP address for the whole thing, which is what we wanted, because then we can SSH into the thing. So there's our printer, there's our server. Here comes our printer. And I'm slowly getting out of panic mode. Once I'm completely out, that's gonna be it. Then we're gonna have fun. The printer is doing printery things to start up. In the meantime, we're gonna check our IP addresses. And by the way, don't worry if you can't hear me while I'm typing passwords. I am intentionally muting myself. There are amazing things that AI can do for you nowadays. And that includes finding the keystrokes to sound. So we don't want that. We don't want that on the internet. So yeah, better safe than sorry. Okay, but we just confirmed that we have an IP address. We need to also check our logs here, and I think this cable is bad. Well, what we actually can do is we can, let's see. Oh, look at that. 5306. So we actually know two systems. By the way, the ARP command gives you the address resolution protocol, which is the way that your local network determines which MAC address, or your computer determines which MAC address belongs to which IP address. And then is able to, if you actually try to send a packet to your printer with its IP address, it then looks that up and uses the actual MAC address to send the packet to the printer. I'll leave it to you to look up the specifics. I actually see that we have DHCP packets receiving now. Now let's look where our printer is registering, because we now know that we have two devices that our DHCP server serviced, 53 and 106, or 50, yeah, 53 and 106, and we don't know yet who's who. So what we can do here is I think it is. And that should be able to tell us what's going on. I can only see half of it because the printer is in the way. That's a bit annoying. What's even more annoying though is the fact that the stream monitoring service is completely running hot now. Because I didn't throttle it, but we're going to do that very quick. There we go, that should do it. It's probably going to cause the monitoring to become a bit choppy, but as long as the stream is not choppy, I'm good. As long as that doesn't get choppy, I'm reasonably satisfied. Okay. So let's get this thing sorted here. Let's move on. We want to actually do stuff today. Oh, I'm an idiot. We can obviously just look up who has a lease. Those are not the leases we want. Oh, those are the client leases. We want the server. Ooh, let's ask the internet before I make a complete fool of myself, because I can't remember the oh, that's no good. That really isn't good. Oh, and I know why. I know why. I know exactly what the problem is. And that's actually why our music cut out. So don't do this at home, kids. I'm actually glad that the streaming connection is still holding up, because as soon as that would end, I would have a hard time to get this started up again. The problem is that our secondary network connection here has received an IP address as well. So if we look at the LAN 3 and LAN, it is now trying to use LAN 3 to connect to the internet. LAN is the one that we actually want to connect to the internet. So a little trick for Mac users: if you have a connection like that, pull it to the bottom, should be good, should be fine now. We can probably reload that, so that is working again. Then we can probably also stop our fallback music and move on to the real world, real one again. Give me just 1 second. Go to the library, press play, and grab OBS again. Well, actually grab Siphon Sound here first. That's on. And we should have desktop audio again. By the way, sorry for playing around here. Reason why I'm so reason why I want this to work so badly is sorry, because it's obviously important that I iron out all the issues, but this seems to be working. There you go. Back to business as usual. The other reason why I want this to work is obviously if I change scenes and I forgot to add the audio to any of them, it's gonna be a bit of a weird day. Although nobody's here to tell me, so you should have been here. You should have been here. I would have liked to see you here. Maybe next time, maybe next time. Again, streams happening every Saturday at 7. And we wanted to look up our DNS mask file. And it says varlib misc. Okay, we can do that. We want to grab this. And what we see here, oh, this is actually nice, because now we can see that our printer has IP 106 and our main system has IP 53. Now the fun thing is we can just minimize this virtual machine away. We just need it to run in the background, do its thing in the background. And we can move on to a terminal session here to SSH into .106. Now this is not going to work. We can accept the fingerprint here, but obviously my username doesn't have a password there, so that's not going to work. So what we want to do here is Control C out of it. We know that the connection works now, and now we can move on to looking at the manual, at the connection description. It will tell us what the default username and password are. We're obviously going to change those, because even if we don't trust this printer, we trust others with our printer even less. And that's, by the way, important to consider. Make sure that as soon as you have a device that could potentially connect to the internet or could potentially be accessed by somebody else, that you give it a proper username and password. Username in this case is going to be a bit hard, and to be honest, I'm not going to bother at all. But in general, you want to do this. The reason why I'm not going to bother is because we are going to replace the main board on this printer anyways. That's just, there we go. That's the username. There's no getting around this. I do want a stock Raspberry Pi in this printer. And because of that, we need to replace the main board. I'm currently considering, rather than grabbing the Octopus from the Trident directly, well, actually upgrading the Trident to the Manta MP5 and then grabbing the main board, I'm considering putting an MP4 in here. Just getting a new Manta MP4 main board, only using 3 of the drivers, or even an MP. Wait, so let's consider this for a moment. We at some point want to build this into a proper dual-link 0. And a dual-link 0 has 4 plus 3 is 7. So I'd probably be good if I got an MP8 on this. And by the way, 7 or 8, because 7 is for the lead screw variant, 8 would be for the belted. But I like the lead screw. So anyways, this is going to connect us now. Username and password are the same. We're greeted with the login here, and what we now want to do is we want to replace this. Now I'm going to mute myself again real quick. now we just changed the password for the login user. What we want to do as well now, just to be on the safe side, is we want to sudo create a new password for the root user. And this is going to fail, so you see that this printer is basically not secure at all. It allows me passwordless sudo. That's a no-go in its own right. So the next thing we should definitely do is we should go to etc sudoers, and here you see the all no password for the percentile sign means group. So the group sudo and the user linear specifically do get to execute any command as an admin user without any checks. So if anybody were to ever get access to your Linaro user here, they immediately would have full control over the machine. And with full control, I mean really full control. Do whatever. If you just have them have access to the user, that is a much better proposition. So while we do want our login user to still be able to do sudo commands, we want it to require a password. So we do want to add the we want to comment those out. By the way, the way you can use Vim or VI here is it's really simple. It's really easy. The most important things you need to know is that you have two modes. You have a command mode and you have an input mode. When you open a file, you're in command mode. You need to press I to insert something. Then it's just a matter of like any other editor. You just navigate where you want to go, and you do your changes. All the keys work exactly like they would otherwise. Once you're done, once you do want to either save and quit, or save, or do other things like undo changes, right? You need to go back to command mode, which is done by pressing escape. And then you have the save command, right? Or the W. So you to execute a command in command mode is you type colon. W would save the file if it wasn't read-only. Now, read-only in Linux, if your root means read-only-ish, because in this case we can save and we can force the saving by adding an exclamation mark that will save our file. That's something you rarely get in other editors, I think. This will completely save the file, save our changes. And now we can colon Q, which will quit. There you go. These changes are not going to take effect until we log out and log back in. And I hope I didn't screw myself now by... Oh yeah. Oh, and we changed the password already. Give me a sec here. So, sudo with a password on a Voron v0. Printer secured. Well, ish. The other thing you still want to do... Oh, we don't need a sudo. you want to check that root access root login is disabled. We also don't need a couple other things here, so let's just get rid of these as well. Also, we could check whether root access is enabled by and this is what you want to see. Right? You do not want to be able to access this printer as root. We're going to SSH back into it. And that should do it. That should be it. Yeah, so initial security is done. What else do I want to do here before I start playing with the web interface? There's one other thing. We want to install Samba. The reason why we want to install Samba is because it will make our life much easier editing configs. Well, actually, and sharing configs. That's something you may want to see as well, or you can do as well. If you, for example, want to use a proper text editor on your I don't know, on your local computer to access your configuration files, you can go that should work nicely now. Yeah, so we secured the printer now. We have it running. We have access to the web interface. Oh, and there's somebody in the chat. Hi, Maria. Yeah, it's going good. Not sure if you read the description. We're building something here. We're building a Voron 0. Not sure if I need artwork, to be honest. For the moment, anyways. I'm just doing this for fun, for friends, basically. So I'm not trying to go super professional, but good on you. I hope this works out. I hope you find much success in art, because obviously there are a couple of cool things you can probably do that me and others can't. But yeah, thanks for offering. Anyways, moving on, I guess. Since we have access to our Clipper config now, we can have some fun with this. What we want to do now is we want to first close up back panel because it's annoying me. It's not necessarily unsafe, but it's not the best. So let's just clean that up real quick. Let's do this carefully. And let's put that back on here. There we go. The other side's going to be a bit more difficult. And by the way, don't do this at home, kids. Don't leave your electronics running while you're working on them. It's a wonder that I didn't screw this up. It is an absolute... I don't understand why this is not broken. Just because I worked on it while it was open. While it was running. But yeah. Please be careful, please be safe. And do not nibble on the mains cable. Those don't taste good. And I just noticed that I had the microphone completely in the completely wrong orientation as well. So today's not my day. Today is not working well, to be honest. But yeah, getting there, getting there. I mean, we're gonna do calibration and then we're gonna print things, and once we're printing things, I'm gonna feel much better about the whole thing. But it took a moment. Somewhere there. And I hope this now stays as it is. But that's a nice business idea, just going around and seeing if streamers need artwork. All right, so that's closed up again. And I mean, even if people don't take you on up on it, the fun thing is you're actually helping them out, right? Just by entering their live stream and interacting with them, they have a bit of a better chance. If I understand the Twitch thing properly, they do have a better chance of being discovered. And I mean, there's just about nobody here, so, and I'm kind of used to it. But yeah, cool. Okay, printer's closed. Feel much better about that now. Much better. Because now we need to go to the Voron setup guide. Let's maybe close that. We don't need that anymore. Now, we don't need to do all the configuration here, but let's check if we need to do anything here. And I assume, and this is something we maybe should check, that the printer.cfg is actually properly set up. So let's check that real quick. The only thing that's not going to be set up here is the filament sensor in the toolhead. We're not going to bother with that now. And by the way, I'm also not bothering with the filament path bound just yet. That's something for later. Yeah, but this looks decent. So let's assume that is correct for the first try. Let's see what happens. We're gonna go into initial startup, and we are going to verify our heaters first. Remember, we did that already last time, but I don't mind just doing it again, just to walk you through this guide, because getting this right is extremely important. Oh, the PID tune we did last time. What we want to do now is the stepper bus. And we have stepper XYZ and the extruder here. So let's just go in here, and we're just going to go to the console because it's nice and big, and we're just going to bus our stepper. and it is rotating right then left, right then left. Which, let's check here. Yeah, it is rotating clockwise first and then back counterclockwise. So that's correct. And by the way, if you're wiring your printer, this is also going clockwise then counterclockwise. There may be a need for you to fix some of the directions. I think in this case the board and the motors are actually set up pretty exactly how you need them. So let's bus Z as well. And that seems to work. It's pretty loud though. Well, we'll need to see if that is actually a problem, if we need to go back and fix or derag anything here, because that sounded loud. It might be because the panels aren't on yet, but it sounded kind of loud. And my microphone is, again, moving in ways I don't understand. Let's see if we can stabilize this somewhat. But yeah, audio is going to be shit in this episode, so, well, it is what it is. I'm a bit disappointed still though that from the Twitch people nobody has actually joined, although I can see why. I mean, it is just about prime time on a Saturday, so maybe that's the issue. We're gonna forego the extruder test here because we already know that it's working in the right direction. Remember last time we already pushed plastic through it? And we're going to move on. We're definitely sure that all the parts are moving in the right direction. Now, the next test involves the Endstops. So we need to send the query Endstops command. And these need to show fully open. So open, open, open. And in this case, it shows open, open triggered. Now, what we need to do now is we need to depress it, and it's still showing triggered. Which means that in this case, we do have a problem here. Our Z Endstop is always showing triggered. What we can also do is we can also try to move our tool head, although no, actually with this and this being with this setup being sensorless, we can't actually move our tool head manually against the sensor to test it. We'll need to test the Endstop as a whole. But first we need to figure out why our Z Endstop is showing triggered, because that should not be the case. And we are using the default cable that came with the printer, so I should not have mounted that panel. This time around though, we are going to shut off the printer because we may need to take it apart further. So we're gonna go to shutdown to make sure that the Linux has a good amount of time to shut down to secure the data on the hard disk, because this is what happens if you don't shut down your printer properly. It's generally not a problem until it is, because whenever you shut down a printer, the Linux operating system, as one of the last steps, will call a sync command on your hard disks, which means that all the caches that are currently still on that in main memory for modifications that the operating system should have made on your hard disk, but didn't have time yet, deferred because of optimization reasons and so on, all those get written with that sync command. Now, if you don't run that sync, you can actually even run the sync command on the command line yourself. If you don't, and I need the other screwdriver here, if you don't run it, then there is a chance that all the modifications are still in RAM. You turn off and they get lost. Now, your operating system is not always making sure that it keeps all the changes in the cache that belong together. So it might have already written back some of the changes, others are still in your RAM, and that then results in corruption of your oh, I need to actually take those out completely. That then results in corruption of your content that was cached, and in some cases that could be even things like optimizations that are made to the way that data is stored on your file system, which in those cases specifically your file system itself can get corrupted. Now, there are backups being stored, but in general, if it happens, it's messy. Yeah. Oh, by the way, also I asked Fysetc for the what's up with the heatsinks, and if there were some supposed to be in your kit, in my kit. They said yes. They said they should have been there. I'm not 100% sure they weren't, but I'm pretty certain. And there was another person who also said that those heatsinks were not in their kit. So there is a reasonably good chance that those are missing in some kits, and I would very much recommend that if that's the case for you, you need to get in touch with them and you need to ask for those heatsinks or some further some further price reductions, because they are obviously needed for running the printer. There we go. Yeah, so that's that. Now we need to take that off, and then we need to, and this is, by the way, what I would expect here is I want to see where the Endstop's connected, right? So we connected the Endstop here, which is the second from the right, the second port from the right, and it is a 3-wire cable that connects to the left outer and middle pin, and then to our end stop on the other end. And what I expect happened here is that that's simply the wrong the wrong pin. As simple as that. There's just not much to it. So what we need to figure out now is whether we screwed that up or whether the documentation is wrong. So we go back here, and what we see here is we have the Z Endstop, and if we follow those lines, it actually shows it the fourth from the left, from the right. The other end stop in the third place is supposed to be the filament sensor that we haven't actually mounted, and that I will not mount here. I would actually much rather have a more direct filament path that I can potentially use an ERCF with, although that's probably going to be a funny thing to do with this printer. But the less mechanical switches are in here, the better. I would have probably used it if it was an optical one, but mechanical, nah, we're not gonna. There we go. Let's move that to the second one from the left. Let's reconnect our display cable that we ripped out as well here by accident. And now that is still off, that is good. We're going to close the mains panel back up because we don't need to get access to that anymore. And I assume that now that we fixed our connection there, that trigger will also show open, and that we can now trigger that as well. We're obviously going to test that before we close up the back panel, because yeah, we just did changes to our wiring. It's probably best to just go over that again. There we go, that is sitting in there as well. That's that. Have these properly secured, and yeah, again, don't do this at home, kids. Please make sure that you always secure your electronics, not just for your sake, but also for the electronics sake. I mean, they are somewhat of an endangered species, right? They live on magic smoke, and at the rate that escapes, yeah, need to be careful with those. Need to be careful with those electronics. They're fragile things. By the way, also a note on safety of electronics, because that's something I completely forgot to mention when we were talking about electrical safety and earthing, or connecting your printer to mains earth. You noticed me moving from a long connection that goes across the whole printer to a shorter connection that is more directly located near the outlet, or inlet, actually, mains inlet. Again, this earth connection, in case anything goes wrong in your printer and for some reason mains voltage gets connected to the housing, to the frame specifically, or is creeping along the panels even, that is something that can happen. Your earth connection is your lifeline, and you want your lifeline, that earth connection, to have a lower impedance than your body. So any energy gets routed mainly through the earth connection and only to a small part for your body, because this is going to be then a voltage divider, and the amount of electricity that's going to go through your body if you ever touch it versus through the direct wire is going to depend on the amount of resistance that mains earth connection to your printer housing has versus the resistance or impedance that resistance, not impedance, your body has. So you're trying to get these mains earth connections to the frame, to the housing, as low as possible, so as much as possible of the energy is actually directed through the earth connection, which means thick cables. In this case, this was a 16 gauge cable. Short connections, so the shorter your connection, the lower the amount of energy that is released in terms of heat. So the shorter cables are usually better at absorbing high amounts of energy for a short time. So yeah, that's what you want. You want a very short, very low impedance cable from your frame, from your housing to your mains earth, right? And be sure that it's actually earth. You don't want to connect any of the others, and then you're good. That's how you should secure your printer, and that's how it needs to be done. Babbling here. Our printer should be booted now. Should have gotten its IP address again. We can try this here, and it is initializing. And now our Endstops are open. Let me maybe show this from the front here. And if I press the Endstop here and I do this, I get triggered, which means that now I'm not pressing it. That should, whoops, result in open again. So the Z Endstop works as well. Cool. What else? XY homing check. So this is going to be an interesting one because I have never dealt with sensorless homing before. This printer does not have an X or a Y endstop. It relies on jumpers on the board connecting. So this is how I understand sensorless homing works. Normally, if you just run your printer, there's no need for a debug connection you need to your printer driver, to your motor driver. But if you run sensorless, the debug connection actually tells the controller board you usually would use the debug connection to debug the driver, right? To find issues with your implementation. But sensorless homing on 3D printers is actually using that debug connection to see increases in, I guess, energy dissipation, or I don't know, like something like that, energy dissipation or vibration. And that data is then fed back through that debug connection to your printer, which then results in the printer recognizing that the stepper motor can't move any further, which is then your end stop. Now, the reason that is good is obviously because you don't need a switch. The reason why that's bad is because it is using a technology that's not designed to handle this in that way. And that would be a bit concerning. Give me a sec here. I need to quickly bump the stream monitoring system to a higher clock speed, because I want to see if my network connection is as bad as it seems. Yeah, okay, so that was actually the problem. I was kind of worried that the stream was somehow hanging or lagging. I'm really curious to see what the replay looks like, what the quality is like, because there are quite a few changes to the tech that I made here, to the setup that I made. Anyways, the reason why it's a problem that we're using a technology that wasn't designed for this use case is because by its nature of not being designed for it, it also introduces some variance here. So you're relying on a detection mechanism that you need to fine-tune very, very finely, very precisely. And any changes in environment can potentially result in that mechanism failing again. And that obviously makes it less reliable. So I am going to look at the printer.cfg here real quick. And we see that the Endstop pin is actually disabled in X and Y, but the diagnostics pin is enabled. Oh, and I might know why this printer sounds so weird. We obviously don't want stealth chop here. What was it? Friends don't let friends use stealth chop? Yeah, you don't want to make your motors perform worse. You always want the most accurate results. And by the way, this might actually be screwing me, because the configuration on this printer may be relying on the driver using stealth chop. And you know what? I need to sit down. I need to sit down. And I think at any moment now we're going to get some cuddles from the little doggy, because he needs to be cuddled as well. And yeah, we just need to move this stuff aside here. I just invited the little doggy. Maybe he comes by for a visit. So let's see here. Oh, okay, so these are already, yeah, right, it's that way around. So these are already in spread cycle mode by setting stealth chop to 0. Oh, and the comment here even says it. And they point to the TMC 2209 for the Endstops, so that is set up in, that's set up correctly as well. Nice. So we should be able to home this printer. Checking that there's nothing in the way here. Making sure that that works out, and then I'm just gonna go for it. I am just going to go for it. This, by the way, being extremely weird. Where are my movement commands? I guess. Ooh, and you can probably hear that, but these are loud. These are freaking loud. Nice. And that works. That just works. Okay. Okay. So I guess we got ourselves a printer. I guess we got ourselves a working machine. I am very curious though why our fan is not working. That's definitely a no-go. And Wow, these are loud. I'm so tempted to just put on a... put on the panels here. But yeah, it's working. It's working. Let's see here. That works. That works. I think you can hear that. It's getting somewhat loud now. Calm. And I guess we need to look for the... We already did the PID tune. What we need to do now, the one thing that's still left for us to do here, before we can at least attempt a print, is to do a bed level. Back on the screen here. So what I would like to do here before I run through the bed leveling is make sure that a distance of 0.3 is actually still a distance of 0.3. So we can still do the paper test, because if it isn't, we have a problem. So what we need to do now is we first need to ensure that our screws are tightened a bit. And I'm gonna use some calipers to measure the height from the actual bed, so we can make sure that that's the case, that they're reasonably well spaced. Otherwise this is going to take a bit longer, because then if you adjust one, the others potentially move. No, need to do it there. And I'm going to just measure this distance real quick. We just need to do it roughly. This is going to be a bit more challenging because it needs to be somewhat straight. If I get it at an angle, it's not going to be a good time. No, that's not good either. But again, it just needs to be somewhat exact. So this is 10.49. So 10.5, I guess, ish. Let's see if we can get this to this to 10. And this will also ensure that we have a bit of room to adjust either way. Right, because we need to be able to move the screws in as well as out. This one's a bit of a hassle. Whoa. And I'm probably not doing myself any favors here. With the way I'm conducting myself, but you know, I'm not good at this shit. Again, I'm a software developer. This is not an excuse, it's just a fact of life. I avoided this stuff for most of my life until I found a taste for it, funnily enough. Nice. And now I'm here and I'm lacking many of the more common skills that people use to solve these problems. Pretty good at software though, but on the flip side, this stuff I think I suck at. Yeah, and that's gonna be a pain. Oh wait, haha, hacked it. I think I need to turn this a bit more still. And now the display is so far in the shadow that I can barely read it. And it's constraining everywhere but where I want it to. So I'm really doing this badly. Should probably have adjusted that at some earlier point. When there was still space to move anywhere. There we go. That should do it. And I am going to throttle our good friend here again, because he's going on my nerves. Nobody in chat. That's too bad. That is really too bad. I guess you guys are not going to see me printing then. We got those at 10. Now we need to find the macro. Oh no, we need to first move to a Z height of 2. That ain't 2. See, this is why you don't run macros. This is why you don't just run macros as they are. Because the height of 2... Oh, damn it. That cable's in the way. Let me show you this. The Voron manual says there is a macro that moves your nozzle to a Z height of 0.2 at each of the screw locations here. So let's grab our mobile cam here so you can see what happens if I move it to 2, not to 0.2, but to 2. Alright, so there's our nozzle. Let's see if we can get it a bit shallower. So we have the yellow field exactly behind it. And now look at this. This is a distance of 4 millimeters. If I move this to 2 millimeters. Now imagine what would have happened if this was moved to 0.2 blindly. That would not have been a good time. That would not have been a good time. So yeah. What we need to do now is, I guess we need to restrain that distance. And let's see if our manual says anything about the initial Z calibration. And by the way, also note that we already screwed in the screws here quite far. So there's something to be said about this potentially ending in disaster. If you just do if you just use it as it was set up. But yeah, we're gonna figure it out. We're gonna figure it out. It's much easier with automatic probes. I have yet, so this is the first manual probe. Kind of curious on to see how that's gonna work out. And I'm just going to move that up a bit so you guys can have a better look. By the way, things like that can happen, for example, if you mounted your rail slightly too far to the bottom or to the top, which then might have an influence on the location of your Z Endstop. So this is something that's probably variable. It can also be different based on like your nozzle, for example, the accuracy of your nozzle, how your hot end is constructed. So yeah, a few things to figure out here. And just to give you an idea here, I am currently reading the documentation. That's why I'm a bit quiet. And it's asking us to do a Z Endstop calibrate here. So we're just going to do that. Sounds reasonable. The paper test, by the way, just so you're aware, I'm gonna go back there. We need, of course, a piece of paper, but what I actually like to use instead, because while being somewhat like, you need to be a bit careful. Whoops. While you need to be a bit careful with it, I like to use actual gauges. So in that case, I like to use these. Right, there's a 35 mil one, or like a 0.35 millimeter one, a 0.13 millimeter one, and a 0.10 millimeter one. And in this specific case, well, actually, in this specific case, we need to experiment, but I have had good results with the 10 mil. Although that was usually too close, so I'm gonna, give me a sec here. I am actually going to use a 16 or 17. and I hope I can find it. Yeah, that looks good. They come in these packs here, and but for the test I tend to just unscrew the ones that I want and take them out, because it's easier to handle. And in this case, so the theory would be that if you print with a 20 millimeter layer height, you want to adjust your printer for a 20 millimeter base layer, but you also want that layer to be squished, and you don't want it to be squished too much. So in this case, I would use a 0.15 as a first gauge, and then we're gonna see how that works out. The interesting thing about these gauges is that they do work somewhat the same way as a sheet of paper. And by the way, your sheet of paper usually being about 10 to 15 0.1 to 0.15 in height. So that should work out fine. But these gauges should be much more consistent because they have a smooth surface. They slide under the nozzle smoothly. They take off any residue you have under there as well. So I like them much better. There we go. Let's move to the mobile cam here. And I think we can safely adjust by one here. And that's almost perfect already, I think. But I do need another tripod. This one's too low. Let's go plus 0.5. Yeah, there's still some room here. Oh wait. And now I can't move the feeler between the bed and the nozzle anymore, so I know that this is too much already. If I go plus 0.5, I can barely manage without pushing the tool head up. If I go minus here, I feel the tool head being noticeably pushed up. So this is actually perfect. Weirdly enough, this number is probably exactly where we want it. And now I have a pretty exact measurement of the height, so should be good. Should be good. Let's continue reading here. Let's continue reading here, and let me maybe also refresh my browser sources, because I'm always getting worried that I'm not sending anymore. So there. Too bad that you don't want to focus here. Well, I guess this will need to do. Yeah, that's our Z Endstop. Our Z height. So they're assuming here that to find the exact position, we should assume a piece of paper to be 100 microns. We used a gauge with 150 microns thickness, so the thing to do here would be to add another 50. So this should be the position. We can verify that by taking our 0.1 feeler gauge, and that should now barely push up the nozzle when we slide it between here. So yeah, it does. There we go. I'm going to leave those here now. They don't need to go back to the SnapMaker. The SnapMaker is not using them at the moment anyways. Yeah, so much for reading. It helps. What else? We're asked to run save config. We have a button here as well, which will then reset our printer and turn off those ultra loud stepper drivers. And remind me that I need to adjust the position of the frickin' microphone again. This is annoying. This t-shirt is definitely not a good location for these. I think I need to wear suits and ties, because ties are probably really good at holding these microphones. Okay, so that's our Z, and now we can actually, we should probably check that. We should probably check in our printer config that the Z value was applied properly. And it probably was. And this is something to look out for. There we go. So that was applied. We still have the problem that our fan didn't run. So what I actually would want to do here now is, oh yeah, that doesn't work. I would also want to those fans sound a bit rough. And those are the ones that we have replaced the original ones with. So does it adjust? Oh yes, it does. Nice. It does adjust. We're going to keep it here. Okay, so that is that. Now we need to level the bed manually. So what we can already do is we can already home our printer. And then we're supposed to run the bed screw adjust macro. Let's do that. And let's actually keep a finger on the off button. Now we can, I guess, take our feeler gauge again and can make sure that that height is what we set with the others, with the center, and that's way out. Wait. So which height are we supposed to adjust it to? So now the nozzle is basically where it thinks 0.3 are, and we now need to turn our knobs out till there is friction. So that would mean that we reduced 0.3 to 0.1. And if we do this correctly in all places, then we should end up with a level bed. Yeah, that should be fine. Let's check that. The idea here being, of course, that you can feel the resistance when moving the gauge under the nozzle, but not so much that it actually pushes the tool head up significantly. All right, that's the idea. This is pretty free. And maybe we should do this from the back in this case, actually. So the feeler gauge lies flat on the surface when traveling under the nozzle. Yeah, that's it. It was pretty good. And we'll see how it actually works out. Adjust it. Let's get this out of the way so we get some light there. And there's probably hundreds of people who are faster than me with this shit, but I'm getting there. I'm getting there. Okay, that should be good. And the last one. There we go. That should do it. That should do it. Okay. Oh, we were probably supposed to do this again until, yeah. I'm stupid. Let's do it again. So this should already be somewhat in place. Yeah, that's fine. Oh, and I get it. It will continue to ask us to adjust as long as we find at least one screw that is turned, and once we don't turn any of them, then we accept all of them. Okay, cool. Cool. Okay. All right. This is how it's done. Okay. See, stuff like that I'm completely missing because I'm reasonably new to the whole hobby of 3D printing. And like if you've been here for years, like decades now, or at least one, you probably know this stuff because you had to do this on the first couple printers. I started with a Snapmaker, well, Snapmaker 2. A year back, 1.5, I don't know. It was some time ago. And obviously I still had to do the Z-adjust, but that was it. That was it, nothing else. Okay, and we get our accept, and now we need to do the Z Endstop calibrate again. But for the Z Endstop calibrate, we want to go to 60/60. Oh, and you always need to do these separately. Okay, so that is that, and now let's go to our Z Endstop calibrate. Let's again use our 0.1 here, and let's go down 1, go down. Point 1. Oh, and this is the new Z height already. Okay. And expectation would be that it stops somewhere around 0.2. Around 0.2 we should get no. Oh, 0.02, I think. No, that's definitely too low. Yeah, that's fine. We'll figure it out. We'll figure it out. Okay, that's that. Okay. Cool. So I just had a great idea. I can use my 1, 2, 3 blocks here to get the camera a bit higher. And that's just high enough. Nice. That is just high enough. Okay. So we managed to do our Z calibration. What else? Oh yeah, slicer setup. Let's go in here. Let's use Orca, and I'm gonna show you what we're doing here. And this v0 already got the name Thor, Thur, or Tyr, I guess is the name. I already set it up. Basically, you choose your, you go to where was that? Let me close this here. There was an entry add remove printers somewhere. Oh yeah, must have been in the settings. What you can't see right now is the menu bar. No printers there. Oh yeah, there's this gear on the printer thing that you can click, and that gives you the printer selection. So what I already did is I found the Vorons, which, starting with V, I could have just grabbed the scroll bar here. And they're not ordered by name. Yeah, so I already added the v0. You can see here in this case it's a v0.1, but it's essentially a 2. It's essentially a 0.2. There is no entry, I think, for a 0.2, so we're good. It should work just the same way. Yeah, so did that, and then chose the 0.1 here. And by the way, we actually need to go in here because I already changed some of the macros. I need to change them back, otherwise our print won't start properly. Selected this, and if you go to edit it and you click the save button, you cannot save it under this name because that is a template. You actually need to choose a different name, and in my case that was Tyr, from North mythology. So you may or may not have noticed that a couple of things in my network are named after Norse mythology. So yeah, there you go. Yeah, that should set up this. In general, we didn't do much here. From other prints, I already have like other filaments set up. We need to make sure that if we print something, it needs to be the PLA. And yeah, I guess we need to print something. To print something, we need to first, add the device, Come on, let's add the device so we can actually control it from here. And we have an octo/clipper that's living on the 192.168.42.106. There's no password, sadly. I'm probably gonna add one. We may need to add an API key. I don't know. Let's see here. I think that was here somewhere. Let's have a quick search. Okay, so people are saying we should be good to go already. So we're gonna do this through Orca now. See if that opens. That does indeed open. So that means that we should be able to just grab ourselves a test object and go. Now, for a test object, I would jump immediately into calibration. And I'd want to start not with calibration phase 1, but I think I'd go immediately to 2. Because it is very unlikely that that we're gonna have more than 0.9% deviation. What we need to do beforehand though is we need to figure out why our fan is not moving. So let's maybe not go too fast here. We already did a significant part. I do want to know why that fan isn't moving. And now that we shut that down properly, we can shut that off completely. And we can therefore disconnect this. Turn it around. And the thing I would do now is I would just disconnect this fan. And run this, and this is something you haven't seen before, I think. We're going to run this fan as a test from our power supply. To do that, I need to move a few things out of the way. That's not as easy as you might think. We're kind of building a little tower here. So we're gonna use our power supply, and I'm just seeing that this image is horribly inverted. No, actually it isn't. Nice, I fixed it. Ha, I fixed it. Cool. So this is a Weigel DP832. And if we get our fan connected to that, and we can actually set the over voltage is set to 12 volts, and the over is set to 12 as well. So we have 24 volt fans. So we want to use 24 volts, and 0.6 is too much. This is probably a 100 milliamps fan, so to be safe, let's set it exactly there. We also need to cable this, so let me dive down and find the cables. Those are not the cables. Those I don't want to use either. We're going to do a bit of banana plug heaven here. So we are going to take our long banana leads here and put them in port 1. And then we're going to take those all the way there. Oh yeah, I actually can keep those protectors. Move these. I have these protectors here so they can't short out while I'm using the other end to plug in my short leads here. It works. It works. And then we're of course going to take this to our fan. Because of the protectors, I can actually just drop them wherever. And in our fan we can, I mean these are DuPont, but even though they fit perfectly well into a JST connector, and this should allow us to yeah, I guess we can start with a voltage of 3.5. I can turn that on. And I think our fan is running. Now we can go to the voltage, move to the yeah. So our fan is actually working. It's pretty quiet, but it is working. I guess the only thing that's left to figure out then is why it wasn't started by Clipper. We can shut this down again. So there, get this stuff away. But at least now we already know that our fan is not the issue. I'm not sure if the fan is supposed to be temperature controlled, so that's something I can speak to. But to be honest, I would prefer it to run, to just show me that there's life in it. But that now also means that once we connected those that fan back, and we obviously by doing this we also tested that the fan connector itself is working. So the thing that's left here is to turn the machine back on, see if we can figure out how to force that fan on. Because obviously we don't want to run our CM module without a fan and without the ability to cool itself. That might not end well. But first we need to disassemble the tower of power here, so we don't have an accident with a very heavy, well, not as heavy, but drill stand. Move that away. Okay, so let's go back here. Let's turn it back on. Oh no, we can't because we haven't plugged it in. And that should boot it up. Those stepper motors are a bit whiny. Those stepper drivers. That's interesting to hear. And there's Clipper, mainsail actually. Yeah, that's home it. And I'm just quickly going to check on the fan config. It must be in here somewhere. Oh, and it is a temperature fan, so it is actually temperature controlled. I am not sure I like that much. We'll leave it at that for now. We'll leave it at that for now. We actually want to print something. So moving the printer back a bit to give you a better look and give me some space to do things while we print. We do want to slice us a nice little test here. The way we want to slice us this, because it doesn't fit here, right? So that's pretty obvious. So we need to cut a few out, and oh, actually what we need to do first is we need to unload our little bit of filament and put in a proper bowden for the real filament, which I'm just gonna add the back panel again. To be honest, it's probably the way to go. I mean, the standing desk is pretty cool, but there are situations when it is a bit high and it's therefore a bit restrained. I could just move it down though. So yeah, I'm being stupid here. I'm being very much stupid here. There we go, that's that. Let's move the spool in place again. And that's that. And we want to add a spool. Now the challenge is going to be getting the filament up there in a controlled manner, because we don't have the, well, I guess we need to add the Nah, I so don't like that. I should have looked at that earlier. I so don't like how that feels, because there's basically no guide for the filament. I would really like to get the filament up here and in through the back. So have the filament come in here. Well, we can just go over the thing. And what we can also do is we can take our practical ECAS fitting to provide us with a bit of guidance there. I'm going to use the blue for this. Because I'm just gonna have it live like this. That should be fine. That should be all the movement range it needs. Although I just noticed I don't like the blue because it is like for guiding the filament to your extruder, you actually want to have OD4ID3 PDF e-tubing, which isn't as stiff, isn't as restrictive, and makes it so your extruder has an easier time. Pulling the filament. And seeing that, I would also want the spool to be mounted the other way. No, actually, yeah, I would want it to come up this way, and worst case about here, because the other challenge will be that this should not get wrapped into the spool itself. So this should be fine. There we go. Cut twice, measure never. Cut again. The other thing we still need to do is heat up our extruder and get our filament out. That piece that's currently in there that I'm actually kind of bummed out I didn't do the whole PTF e-tubing thing earlier. But we can just set this at 210. And I just found out how to turn on the fan. Nice. Okay, that's working. Our hot end's heating up. That looks fine. Music still seems to be playing. Since nobody's here, nobody can tell me that it's shit, so you guys deal with that. Yeah. Hot end fans running. The hot end itself is oozing. So yeah, good times, good times. There you go. There's the printer. We are at a bit over 110, so let's retract here. Let's retract again. Oh, and what we actually would need to calibrate first, I think, would be the E-step, because we can only do all the other calibrations if our E-step is correct. So let's do that first, and we can actually use this for the E-step. That's good. What we want to do here is we are going to measure 7 centimeters on this. And I'm going to cut off the curly end here. We want 7 centimeters. $706, okay. 6997, 701, 702. 701 it is then. We can measure that here, and we can then take a bit of tape. Oh no, I would actually want to load this first. I want to load this first, and now I can measure this. We're gonna measure our 7 centimeters from the top, and I am going to try to get a piece of tape on there. To mark where those 7 centimeters were. And then the expectation is that if I extrude 5 centimeters, that 2 will be left. The difference will tell us how much is actually left. The reason why I'm not just gonna do 5 is because then, especially with measuring it so close to the ECAS fitting and the print head, I do want to still have, like, I can do micro adjustments on that level so close with the calipers. So I'd want to have some base value to measure against. And we want 50 here. Want to extrude 50. That was not 50. Oh, it was 25 and twice. So if we measure that now, we can check the actual length. And that's 1.69, which no, 1.79, so almost 1.8. And then there is a handy dandy website. Was it here? Yeah. Teaching text. E-step cal. And here's the calculation. So what we want to do here is we want to multiply that let me see here. And I need to sit down. Ugh. Getting too old for this shit. Ooh, and that's another thing I did wrong last time. When we talked about movies, and I said that the quote there was from Lethal Weapon. No, it wasn't. It was actually from Dark Angel. It was a quote from Herbal. So if you have not seen Dark Angel, you should definitely check that out. It is one of my favorite series, and Danger Will Robinson. There is a rant coming because Dark Angel and other series from the time have so much better writing than TV series nowadays. It is laughable. There are a couple of series that are really good, I think, in terms of writing style, in terms of writing quality, but most TV series nowadays seem to rely on shits and fucks to get their audience instead of properly forming sentences. And while I do like my shits and fucks, I think sentences are a really, really practical invention in their own right and should not go unnoticed. So there are a couple other TV series I like in that regard. For example, God Omen. And yeah, God Omen has it. But you know what? God Omen is made from text material from Terry Pratchett, so I would expect it to have it. On the other hand, if you watch like any other TV series, looking at you, Game of Thrones, looking at you, The 100, looking at like, don't get me started on The 100. That series escalates into insanity so fast. But in general, please produce better TV series. It is no wonder that language and by some extent the attached culture is going to shit because people just don't put any effort into writing and maintaining it that way anymore. In days past, language was maintained by writers having some pride and actually writing good sentences, good structure in their own books, because everybody could read those, and any mistake they made, anything they did wrong, anything they could have done better will haunt them forever. And that was how language, I think, got maintained, because there were authors and they had some freaking pride in their work product. But nowadays it's just about viewer count and popularity and getting the youth and the youth speak and everything like that into a TV series. And if I hear fuck 3 times in the first 5 minutes in a TV series that's supposed to be about culture, about something, well, even sci-fi should have some aspiration to do better than the youth on the street, is my personal take on it. And again, I don't mind the occasional over-the-top swearing. I don't mind at all if that even becomes a running gag in a TV series, or this occurrence that happens every once in a while, and that makes everybody laugh and enjoy themselves. No problem with that whatsoever. But to overuse it to cater to youth, I think shows poor judgment and shouldn't be supported. Just my 2 cents. I'm still watching some of those TV series. So, Doctor Who, by the way, the TV series I always quote as an intro in some form or another, does this reasonably well, because their authors still seem to have some pride and some dignity left. There you go. I think rant over. I hope I offended somebody, because that means that I was right. No, I'm kidding. Obviously, I don't want to offend somebody or anyone. I want to express my opinion here that in regards to the writing style and writing quality of today's TV series. And if that strikes a nerve for someone, then maybe they can aim to do better. Or maybe I'm completely off here and they are already doing better and I just haven't seen their TV series yet. Then please put it in the comments. Please, please, please put it in the comments, because then I want to see. Then I really want to see what's up there. And yeah, just prove me wrong, please. Ooh, and I think we have a guest here. I think we have a guest here. Want to say hi? So hi. Come on. Come on. I think somebody needs attention. Come on. Yeah, there we go. Somebody needed attention. Yo. Yeah. Ja. No. Dankeschön. Yeah, he's good. He's a really good dog. He had a really long and exciting walk earlier today, and a good helping of food. So he was quiet the last couple of hours, but looks like he needed some attention. Yeah? Yeah. Na komm. Na komm. Kannst du wieder hoch? Kannst du wieder hoch? Na komm. Na komm. Hey. Hey. Hey, hoch. Hey, hoch. Yeah. Yeah, this is my other spare time activity. I only have room for 2. That's fine. Come on. I only have room for 2. This little guy here takes on quite a bit of time. He needs to really get his physical and mental workout each day. Well, mental more than physical. Physical with these guys isn't as important, but if they are mentally not stimulated, then they really don't have a good time. I really don't have. Anyways, what else? Yeah, so we're at the E-step calculation. So we had a, and let's put up Python here. Let's pull up Python. Yeah, I know that went. There we go. So we notice that our $50mm extrude actually extruded 50.2 because we measured 70 and we had 1.8 left. We should have had 2 left. So that is our actual extrusion distance. Actual divided by requested means that we need to divide this by 50 Oh wait, 1.8 would be 52. That is 1.04. And we need to multiply that by the previous rotation distance, which we can find in our configs. Let's not select too much here. Let's find the extruder. (22.23 times 1.04). Oh, no, obviously this needs to be 22.23. That's 23.1192. So we need to change that here, I guess. And what we're gonna do is we're going to keep the old value and we're gonna use 23.1192 and save and restart. Now that was slightly dumb. Go, because we obviously still need to remove our filament, because this is now definitely too short. Well, actually, let's check it. No, we really want to remove this, because if we don't remove it right now, it's going to be impossible. Like, this is probably way less than 70 millimeters. So it would just get sucked into, yeah, this is too little. So it gets sucked into the extruder, and then digging it out from there would need to disassemble the whole thing. And nah. We would just waste more filament by then calibrating that out. So I'm not gonna do it. I'm not gonna do it. High Freedom Infinity 3D? No, I'm not. I do this as a hobby. I'm actually a game developer, and I avoided doing any construction, any building like this, like any kit building like this, or engineering of mechanical processes for most of my life. Something that I do regret now. And yeah, this is just a hobby for me. This is just, I'm just trying to wrap my head around it. But hi, welcome. Anything else you want to know? Where are you from? And that's at 210. Feel free. I mean, it's just us two here, so let's have a chat. Okay. Oh, I can't actually. Probably need to home it first. By the way, Freedom Infinity, how's the music? Is the stream still stable? Because this is the first time I'm actually streaming both to YouTube as well as to Twitch. I've previously only been streaming to Twitch, to YouTube, and I'm kind of curious on how that's working out. Let me know. I'd be very interested in hearing how the stream's doing. Weird. And by the way, if you want to see what I'm doing here, there we go. Here's the calculation of setting up and calibrating that distance. And here we are right now. I'm not 100% sure why the retract features weren't available, but it seems I just need to reload here. And let's get this out now. That's that. And let's get the other one in, because now it's time to print something. I want to print something. I really want to print something. So that's in there. It's in there as well. Not coming out. Nice. There we go. That was slightly hot. Yeah, so much for not maiming myself here. Enough chances to actually see myself getting hurt. How do we want to do this now? I'm kind of tempted to lock this down some. Well, we're just gonna leave it that way. We're just gonna leave it that way for now. And now we're gonna do the calibration here. The interesting thing on these is that they actually have the value on them. And maybe we can use a... Wait, let's close that. Different color here. Oh no, they're out. Let me see if I can actually... Let's use that for PLA. Let's use this for the ASA. Oh. That should be fine. And I think if we make these blue, no, you can still not see that. Yeah, that's probably best it gets. You can see that these have numbers on them. And what I'm going to do is, this is actually the second part. This is actually meant as the finer calibration, but I don't see the point of printing the large calibration with the higher numbers first, and then this. It's just such a waste. Well, actually, let's do it differently then. We can still look at the higher numbers and get a few prints in there, but we, for example, don't need the 20 or... Whoa, shit. Yeah, let's just create it again. We don't need part minus 20 or 20 or... Because the other ones have 10 steps, basically, 0 to 9. And what we want to do is go plus 15. That gives us 15 to 5. Then we have 5 to minus 5. And minus 5 to minus 15 will give us basically everything we need in these 3 prints. And that should be sufficient to give us a baseline for the other print to then cover the rest of the range. If we slice that and look at our not line type, but no, it should actually be flow. Then these should be different. Oh no, they would barely be. So yeah, let's just see what happens. And obviously I haven't printed the temp tower yet. Need to figure out flow first. Also, this is the quicker, faster print. Easier print as well. If we look at our duration, this is only going to take 13 minutes. And while I am not as concerned about gases here, I will still fetch the air purifier so it can do its job. It's a bit dusty, I guess. Needs a cleaning. Well, for a first print, this looks promising. Oh, and the dog is getting his taxes. Or he needs to be cuddled. Warte mal. Warte mal. Sorry for the noise level, but I can actually give you a good look at the print if you want. There you go. Printing. I'll have to look at that first layer. It seems a bit too... like I think I want a bit more squish, but in general, I mean, it's doing it. It's laying it down. And this is the first print of this printer, so there you go. Na, komm mal hier. Na komm. Komm richtig hoch. Komm richtig hoch. Na komm. Hey, Enek. Hoch. Ja. Ja, richtig hoch. Na komm richtig hoch. Alles gut. Alles gut. Komm richtig her. So ist gut. Ja, so ist gut. Guck mal, was hier los ist. Was hier los ist. Yeah, there you go. Now is the time when it would be really good if somebody else joined the chat. Well, somebody at all joined the chat and talked to me, because my desk is so full that for the next 13 minutes I basically can't do anything. And if you don't tell me what you want to talk about, I'm gonna pick a topic. Yeah, so what else can we talk about here? Well, and I'm going to need a noise gate here on some level, because this seems to be rather loud at the moment. But yeah, things are happening. Things are happening. Let me check here if the extrusion settings are actually sane. Yeah, those are fine. Nice. Oh. Well, I guess this is working. What we can do in the meantime, though, is some panel foil removal. Or paper removal from the panels. So we can mount them. Yeah, so that's it. That's that. There you go. Printer's printing. There's definitely some work to be done still, but it is doing it. It is doing it. And by the way, Freedom Infinity, if you want to be part of a stream again, I am streaming. I'm not sure if I'm going to start the Monday series this next coming Monday, because the Monday afterwards I will be quite a ways away. but I am going to be streaming again next Saturday at the latest, and then probably with some more involved changes to this printer still, calibrations, mods and so on. But there are a few other interesting topics coming up as well. This is actually the easier printer to build compared to the other topics. I kind of used this build to just get the stream calibrated, to get all the tech figured out, and once we have that sometime early April, we're going to go into something that's quite a bit more involved even. So there's at least 2 more printer builds and a couple of rather involved mods coming up, because my colleagues were complaining that they wanted to see how I'm doing it and what I'm doing and how I'm failing. It's probably the most important part here, because yeah, this is completely out of my comfort zone. But it's fun. Ooh, that was a nice one. And these panels look pretty cool. Let's maybe check, because these are notorious for being out of spec. So these are 2.75 millimeters wide, so that should be just fine. Another 0.25 millimeters would have been nicer, but I guess. Oh, and if you're interested in how we got here, the recordings of previous streams are available on YouTube. I would watch them at least 1.5x, potentially 2x, because they're quite long, quite involved, but they can give you a pretty good idea of how this machine came to be. Ooh, and that's it already. Huh, nice. Then let's have a look here. So, and this is maybe interesting in general. So let's move to the overhead camera, and let's move you out of the way for a second. There. Let's move in really close here. So the way this test works is to see where it over or under extrudes, and with the top one, so the thing you want to achieve is you want to have this flat, so no ridges forming above, and then you also don't want any holes. So I will need to grab magnification right now and something I definitely had to do is get a set of a bit less awkward magnifiers. So these still have like 2x magnification, and they have lights in the front. I'm kind of hoping these still do. So let's have a look. And I would say this here definitely has ridges. So this is definitely over extruded by a lot. Even the 5 does have ridges. The -5 is, and by the way, these are percentile. So -5% flow seems to be good-ish. I am worried about the quality of the corners though. That actually looks quite ugly. And the bottom layer is far too high. Well, you can see that here. You see how these lines barely got squished into the surface. That's definitely not something we want to see. So we can adjust our Z height somewhat. That definitely needs to happen. And I can see issues around the number 5 that are probably under extrusion. So I would start from the +5%, so 105% of flow rate and move to 96. So what we need to do now is we need to go in here, we go to filament, go to the, oh, and we were at 98, so that means we're going to get a range of 103% to 93. So let's put in 1.03. Let's save that. Let's definitely move to our prepare state again. Oh wait, we first need to go here. No. There. Select these and get rid of them. And then we need to bring in our phase 2, where we don't want to print the 0 again. I mean, why would we? And I think we can, because it doesn't fit here, we're going to scale this down to, let's say 90. Let's move it in the center here. Slice it and Oh yeah, what we wanted to do is we wanted to adjust our Z offset. So how would I go about reasoning about the, oh, you probably didn't see that, but we went through the, let me walk you through the process here real quick. I went in here in the material settings. I had a flow rate of 0.98, changed that to 1.3 because we want to see the results between +5 and -5%. So that's what we have on the plate now. Went in there, got the calibration print, set it to this, and now what we're still going to do is we're going to adjust our Z offset. Now, how am I going to approach this? I can clearly see that if we look at our prints here, you can clearly see that these bottom layer lines are intact. They're just there. So they were basically laid down and they just stuck there in place, but they barely got squished, or at least didn't get squished as much as they should have, which means I would want to adjust the Z height by at least another 0.5, and I can do that either in my slicer here or on the printer. Doing it on the printer would mean that it would be active for all the prints, but that may not be something we want. So for now, let's and this is also why it's good to experiment. We're building a full plate now, so we can get a good idea of how evenly this is distributed, and we can go 0.0, right? Because we have a 0.20 millimeter layer height, which means that we do see some squish, but we want to probably adjust it by 0.03 at least, and see what we get there. So I'm gonna save that. Minus 0.03, we're gonna slice it. Then we're gonna print it. And then it's gonna get loud again. And I was actually thinking that I could get some project work on the prep for the Monday project in. Oh, and by the way, if we want to print something, it might be good to have a print surface. So there. That would have been a catastrophe. It wouldn't be out of character for me to forget the print bed, but it would have been a catastrophe nonetheless. Nice, that looks good as well. Oh yeah, and by the way, if you want to know what we're going to print as the first official print of this printer, we're of course going to do the Wilson airless basketball in, what's it, 50-ish%, maybe a bit smaller. So this is what we're going to print when we finally have this printer set up the way we need it. That's going to be fun. I basically need one for a godchild, and while I could just go and print it on my existing printers, I think it's the perfect, absolutely perfect model to print as a first print for anything. In the meantime, I am going to set this up again so you can have a look at what's happening. I am already noticing some things that I don't like about the hot end here though. It seems to be quite messy, so I think we need to exchange the hot end quite soon. Whoa. Poking holes in the air purifier here. That does not look quite correct. Actually looks like it's under extruding, especially around the corners there. We'll see. I am a very bad judge of first layers, to be honest. So we'll see when we turn it around, and we have a couple other prints that we need to do as well. I will kind of aim off getting that first layer dialed in during those other prints. So yeah, it is printing though. It is printing though, although not very well. The corners are getting better, I think, but we'll need to look at those. And this is the last peel. So I think that's our top here. That's the one we can't add. Definitely can't. But at least we have the peel off these, so we can add them to the printer whenever we want. Yeah, and these first layers look abysmal. They all look severely under extruded. Although we know that well, let's look at these again. real quick. Let's switch here and let's see if we can focus these. No, we can't. Damn. So I guess the thing to do here is take the printer camera and move that here. So we can have ourselves a bit of fun with the details camera as well. There we go. These are the 3 prints we got. -5 at the smoothest, but probably already too much under extrusion. -15 at the roughest, but even 15 has these corners here, or these edges between the outer layer and the inner, and yeah, I think we need to do something about that. Otherwise, all the other calibrations will likely be moot. But it does look like we're coming out at somewhere between 5 and -5. So if we end up at a -5 in this test, that would put us exactly at the stock setting, which would make me feel very good about our E-step. And that would mean that our problem is not the E-step, but is somewhere else for these. Yeah, but it is printing. It is printing. I'm glad it is printing. And yeah, as previously stated, this is a printer kit that barely costs 350 bucks. Well, in actuality, it cost me 340 bucks delivered within Europe. So yeah, at that price, it is doing well. It is doing well. There is some room for improvement, but in general, and there's a I don't want to call it a review, but there's definitely an opinion piece of myself and a discussion of the shortcomings of this printer coming up, but not today. Not today. What we could do though, since I have at least a little space. Oh, it's a bit hard to actually include you guys and keep the print in focus at the same time. I need a print camera or a print layout where I can show a print running while I'm talking and doing things. And I think the camera is actually focusing on the wrong thing here. Let's see if that does anything. We can get a better view this way. And yeah, you can see it. This whole process is still somewhat experimental. I'm learning here, not just building printers, but also tricks on how to stream it well. There we go, that looks good. It's too bad you can't see the cat ears on the tool head. I don't like the corners on those prints though. You can definitely see that there's something wrong there. There's no question about that. And it's in all of them. So I guess we need to figure out our pressure advance. But yeah, so that's the build. That is the build. We're gonna calibrate the hell out of it. And once we're done with that, once we have all the problems figured out, we're gonna print ourselves a basketball in orange, if you can believe it. Hey Omar. Oh, nice to see you. I'm currently printing calibration pieces. Like you need to calibrate the whole printer to make sure that the filament is being pushed in the right speed and with the right amount. So that's basically what's happening right now, is the filament getting calibrated. Each of the pieces on the build plate has a different flow rate, it's called, multiplier applied to it. And by checking all those flow rates, we can then check if we need to increase it for this material or not to get better prints. In general, it's looking good, but there are a couple of problems that are already very much visible that will need to be solved. Like, I already printed a plus minus 15% set. So if you look at these, let me see if I can get these in focus anywhere here. I need to zoom out. Oh, the space is actually inside here. So if you look at these, you can pretty clearly see that there is a problem between the outer rim lines and the inner ones. So that's definitely something I was not expecting, and I have actually never seen in this or this pronounced. I was hoping that it would be better with the next prints, the ones that are in the print bed right now, but I don't think it will be. I don't think it will be. They all look quite rough and ready still. And by the way, that's something that we may not get a handle on until we do some more radical modifications of this. So like this is not the printer configuration I ultimately want to run. The hot end, so the thing that actually heats up the plastic in this, is a turd, to put it mildly. And that turd definitely needs to go. It is extremely slow, so I don't think I can print much faster than 12 millimeters per second with it. 12 millimeters cube per second flow rate with it. So that's already quite limiting. But it also is not exactly the most high quality one in terms of precision. So to be honest, it was expected. It was expected, and there are things that need to be done there. But I do already have the replacements, and I'm actually looking forward to it, to pushing those in, to getting those set up. But at least it is printing. And I think we can do quite a bit here, even with the current hot end on there. I think we have a good basis. Yeah, I got it working, and it's actually working really smoothly. So it's loud, but it is working smoothly. The motors are quite whiny. But it is a printer, and to be honest, I think part of my complaints about it being loud are stemming from the fact that there are no panels on it yet. Right? As soon as the plexiglass panels are on there, it might actually get more quiet. Yeah, it's pretty stable. It looks good. It is good. Can't complain. There's no binding axes, no obvious mechanical problems, at least not from what I can see until now. It's likely going to be much more on the fine tuning and precision side. I think after this print I will redo the E-step just to make sure it's correct. And yeah, you wanted a print stream, so here's your print stream. All that's left is print, and then do settings in software. Which, by the way, if you're interested, let me see here. Looks like this. This is the control interface. You can see that we're on a 60 degrees print bed with 220 degrees filament. The MCU is getting cooled quite well, but the fan's running 100%. I did all the calibrations earlier. Oh yeah, so that's the thing. That's the thing. The basketball is very hard to print. I don't think you can do that easily. And I'm not sure if we can actually do it with this printer as it is. I think we will need to have the new hot end installed and a bunch of other things before we can make that work. So let's stare at the results here. And for us to stare at the results, I will move the other stuff aside. There we go. Hot off the press. Very hot off the press. I am going to grab the glasses. And by the way, Omar, I got myself a new pair of more socially acceptable magnification glasses. I mean, these still look weird, but they're less weird than the whole contraption that goes over my head. What the hell? What is going on here? So these have numbers on them. There are no numbers here. Okay, I think we will actually need to print that again. Flowrate pass 2. These. Let's size that. .9. Whoa. No. Let's actually do. These calibration tests are pretty special, so they're usually very fickle when it comes to modifying them after they have been added to the build. Let's just print it that way. Let's slice this. And let's check if our numbers are still there. This is weird. This is very weird. Let's remove that and let's then Flowrate pass 2. Let's add these. And then we're just going to remove a bunch. We don't need 0. We're going to look at -1, -3, -5. -7, 9. And we can just move those closer in here. See what happens if we slice that. Yeah, now our numbers are there. The importance of those numbers is that yeah, if they are not there, then the settings are not applied anymore. And I think that's the problem with our current build, is that these settings are not applied. The good news about the current build is that our results are very consistent. they get squished down very well, so I'm quite happy with how the layer itself goes down. But there's definitely something wrong in the settings when it comes to connecting the fill lines to the outer lines. And I definitely need to move on from this PLA stuff to ABS, because PLA, you know what's funny? Let me see here. You know what's funny about this PLA stuff? It's a bioplastic. So I think it's made from cornstarch or something. I don't know. I haven't ever looked into it. So you'd kind of expect it to, or if you were sold something like that, you would kind of assume that it's environmentally friendly, right? The spoiler, it isn't. It's one of the hardest to recycle plastics there is. The plastics I usually tend to print with ABS, nylon, polycarbonate, right? Those oil-based plastics, where you would think they're so bad for the environment, they're so bad for everything. The fact is, if you want to recycle anything, those are the ones you can. ABS you can chop up in small chunks, in like 5mm square chunks. Then add 50% new virgin material to, and you can basically reprint those or reform those. Nylon you can just hack up and extrude right from there, or not extrude, but make new filament or make new material, new pallets for right from there. It's almost infinitely recyclable. The only thing that keeps you from recycling is if it gets contaminated by like dirt and oil and other stuff, right? So that works out quite well. And polycarbonate, your CDs, you can go, well, it's actually pretty hard to hack up and recycle any plastic, right? You need to make sure it's clean. You need to wash it so you don't contaminate your facilities. There's a bit of complexity to it. But your CDs, you could also just, if you actually get them hacked into smaller, like somewhat homogeneous sized pieces, you could also make filament or new CDs from. Because it's like polycarbonate is a really well recyclable material. The only stuff that isn't is stuff like this, or PETG. Right, so the two most used filaments in 3D printing are the worst in being recyclable. There you go. That puts a damper on all of this. So I need to move on to ABS again. It's just, I don't know, it's, apart from like ABS, you can't print without a housing, but without the panels on, you need an air purification system and everything. Otherwise you may poison yourself or fill your body up with carcinogens. That's the other side of the coin, right? This stuff here barely leaves any any residue in the air, or barely expels any residue into the air. But your ABS and ASA and nylon, they do. They can be quite interesting in that regard. Okay, so what am I thinking here? I'm thinking that we want to print this again, but I also want to try something. We basically don't have infill. Let's do no, let's actually remove this. Let's remove this and let's instead run a generic PLA. Let's set this at 1.03. That's 12 mil per second, chamber 0, and it's all fine. Layer times are fine. No cooling for the first layer, okay-ish. Yeah, let's try that. I'm kind of curious. I mean, the result for the flow test is probably going to be the same. The interesting part is going to be whether this fixes our first layer issues. Yeah, though I'm not sure if like a life cycle analysis or any kind of viability analysis is actually something that's really relevant here, because the best thing you can do is not about recycling, right? The best thing you can do for the environment is reduce dependency on plastic and non-recyclables in the first place, right? The second best thing is if you can find a way of reusing your recyclables. And recycling itself should only come into play whenever you really can't reuse them. right? When you're done with them, then they need to be able to be recycled. That's the problem. I mean, most of today's cars is ABS. And if you have a lot of custom formed parts nowadays, right? If you went to, like, let's say you had a car a couple of years ago and you were looking for interior, you could probably make the interior of another car fit. That's not possible anymore because every single car has custom formed parts up the wazoo that you can't fit anything else. Every single car bumper is probably different. I mean, I'm kind of glad that that in Germany we now have a mandate for delivery services that they need to also have a recyclables option. So you can get your food in recyclable containers. The system behind those is a bit shit though, because like if I order somewhere, right, and I don't order there for 2 weeks, then I may not get my deposit back. And I mean, the goal should not be to get me more Tupperware. The goal should be to, reduce the amount of non-recyclable or like less recyclable shit I get with my food each day. So the ideal service that should be rendered there. Oh, and I totally forgot to do the E step again. The ideal service that should be rendered there is one that takes those containers with the next order, and then like if everybody uses the same containers or like the same format of containers, then you have something to work with. But if everybody does their own thing, and some require you to even clean it, some don't, it needs to be really easy. As a customer, I want to get my food and I want to give the guy I ordered food from next day or next week or 3 weeks later a rinsed but not washed container, and he needs to take that and take that back to the restaurant. And ideally he does it in a car with an electronic with an E motor and not with a diesel. That would be ideal. Wishful thinking, I guess. Those first layers still look... I mean, the first layers themselves look good, but... Those ridges look shit. I'll need to, like this may actually be a, let me check something here. This may actually be a problem with the way these are generated, because these are actually generated models. Yeah, I don't know. They should be fine. Yeah, there's something funky about this extruder. But at least this doesn't need all that much filament, and as soon as we have the thing calibrated, we'll not have to do it again anytime soon. So with this couple of grams, I don't feel all that bad about it. Probably less than I should. But I do need to check Twitch here though, because I actually got it working. I actually got it to work where I can stream on YouTube and Twitch at the same time. It was a major pain in the butt though. Yeah, it was. It ain't easy. It ain't easy. How do you mean checked? Yeah, there was one other guy here earlier. He gave me a follow, so I'm kind of hoping he will join sometime again. Oh, that's going to be a disaster. This print's going to be a bit of a disaster. Let's see. Let's see. No, it's not different. It's exactly the same stream. The Twitch guidelines basically state that you need to stream, like the users should not have any, how do they word that? Basically, Twitch users should get the same service. There is one exception I'm doing here, is that YouTube actually gets the 1440p stream, because you just can't do it on Twitch. It's just they don't have the facilities, it seems. Everything on Twitch seems to be 1080p. But otherwise, and by the way, I don't see a point anywhere where I will ever not stream in 1440p on YouTube. That's the part where like I would definitely not honor anything that Twitch wants. If they want their users to be to get the same service, they need to enable 1440p basically. But yeah. Well, no, at that point, I mean, it's not like Twitch got me any more viewers than YouTube. And I think that especially for builds like this or for streams like this, 1440p is actually reasonably important to still be able to make out the manual, to still have that render somewhat legible while you have a big part of the screen dedicated to the action. And if you do that in 1080p, the manuals look like shit. So that's something that that where the ball squarely in the wheelhouse of Twitch, and not my issue anymore. But otherwise, funnily enough, you know what I'm streaming from right now? You know what the camera is I'm using right now? You can see it. This thing. It's a Samsung Galaxy S9 that is streaming webcam footage, so you can actually use this as a webcam to my computer via a special app and tool, but it is streaming 1440p. And like if you I'm just gonna show you this real quick. If you look here, right, this is the whole setup. There's by the way the stream monitoring and the setup and all the other stuff there, and I have two freaking huge cameras that have amazing quality, but this little shit of a phone, it already gets you 80-90% there. It is so hilarious. And by the way, this phone I bought used for, I don't think I even paid $200 a couple of years ago. You can probably pick those up nowadays for like $100 to $200. And as a camera, like it blows the iPhone out of the water. And I love my iPhones, right? I'm primarily a Mac user. But and I do primarily use iPhones and all this crap from a company that seems to not give a shit about laws that are meant to protect customers. So yeah, kind of peeved about that. But they already had good cameras, but this thing, if I was this close to the print, the iPhone would already have issues focusing. Like this especially for details, especially for going really close to things, right? I just showed you the details camera, right? This big beast there with the 40 to 150 lens and going really close to something. But look at this. Look at this. I can do almost the same thing with the phone It's insane. The problem, of course, is that you then have to have the phone close to it, and like I still like the camera setup and the lens all the way up there, because I can zoom really far in. And still work and still not have the lens in the way, right? With the phone so close in, it would get a bit awkward. So the camera and that big lens and all that, and the higher, it still gets me higher quality, and the manually adjustable zoom and focus, all that still has its right to exist, and I'm glad I have this stuff. But this phone is insane. I'm not sure if their cameras are still that good, but this one is. And yeah, you're completely right. That is reuse. I specifically got that one for playing with the Gear VR a couple years back, and at some point while I was setting up this stream project, it dawned on me, hey, you still have that thing and it never did anything for you, because the Gear VR, I'm not sure if you still know it, was one of the earlier VR devices where you just had the lenses and the headset, and where you then put in your Android phone to have that actually render the screen at 60 frames per second at the time, right? Nowadays we're at 90. That was fun, and it was fun to play with, but as soon as the Quest 2 was released, I went for that, and I've never looked back. The Quest 2, or Quest 3 now, if you want to get into VR, is, I think, the best way to enjoy it. But yeah, still, I'm glad that that phone exists. It has had a couple other uses as well, but even in 2024, it's definitely no slouch. The build quality is good. The battery still holds for ages. I'm not sure why people buy new phones nowadays. I'm not sure. It doesn't make sense to me for anybody to still buy a new phone. That just isn't. I mean, thinking about it, right? And there isn't even anything they still offer that would be worth buying, if you ask me. I mean, why do I need a, I don't know, faster graphics chip in there? Why do I need a faster CPU in there? Most of the other stuff is well, the screen can be a couple nits brighter, right? There's maybe a new connector on them, but you tell me, what were the last significant changes to mobile phones? What was there? I mean, even the CPUs and the CPU power you can get is yeah, exactly. There's just no changes, or no significant ones at the very least. There's something cool happening with like the flip phones, right? That I find to be somewhat of a cool trend. Yeah, forget AI. Forget AI. AI is not a feature of a phone. AI is purely a feature that you especially when you consider phones, it's a feature you usually run on servers. And you could probably use the same AI features with a phone from 15 years ago. Yeah, but that's, and I mean, yeah, but this is like the whole innovation in general. Look at the gaming handheld craze, right? It's the same thing. They're all holding back. They all give you incremental changes, even though they could completely change the world. The only thing they think about is that they still need to sell you a new phone next year. They have foldable screens now, so where's the rollable screen? Right? Where is it? Where's my ultra thin foldable? Where's my screen only and like translucent electronics? Where's that stuff? It's not that like that's impossible. Just, and it's not even like those companies haven't played with that before. They've shown prototypes, but they want to sell you what comes from those prototypes in 15 to 20 years. And with the gaming handhelds, I'm actually really disappointed, because I was looking at, for example, buying one, right? Buying a Asus ROG Ally or a Lenovo Legion Go. I also looked at the One X Player X1, and the what was it? The MSI Claw was the recent addition. But they all have their shortcomings. They all have something I really don't like, and some things that just don't make sense in some cases. Right? You have your Asus ROG Ally, ingeniously light, really well-performing device, but grip ergonomics are somewhat meh, and the screen is one of the smallest in the field, so pass. Lenovo Legion Go has detachable controllers like the Nintendo Switch. Awesome. Exactly what I want, because then I can use the thing as a tablet as well, and I don't need another device. Also a form of reuse, by the way. Yeah, problem is that if you have a tablet that's just a tablet, then yeah, you run into issues with sound quality, because you can't have the sound, the speaker pointing at the user anymore. You now have to have it point upwards or downwards, and that kind of sucks. And they made a couple compromises there as well. But what bugs me most about those two devices is that they both came with 16 gigs of RAM. And 16 gigs of RAM for a gaming device nowadays, yeah, it's, I mean, the sweet spot for, like, they have IGPs, right? And the sweet spot for memory allocation to the graphics card is 6 gigabytes, which means of those 16 gigabytes of RAM that you have, what's left? What's left? 10. And 10 is even less, right? You have an IGP, you're sharing the memory with the IGP, so it's, I don't know. It all doesn't make sense. Now you go and you look at the 1X Player X1, which is a fantastic device. It has a like 10.9 inch screen. That's awesome. It has detachable controllers, it has an attachable keyboard, you can use it as a tablet, you can use it as a laptop, you can use it as a gaming handheld. It's a bit heavy, yeah, sure. It has 32 gigs of RAM, but they decided it would be cooler to use an Intel APU with the Intel Arc graphics. And while I applaud them for trying that and giving the Intel chips a chance, it also means that that device I can't buy because performance sucks. And they have 32 gigs of RAM, but what the hell am I supposed to do with RAM if Intel can't build a graphics chip to save their life? Okay, let's have a look at these. Let's see what we got. It's a bit frustrating. But you know, the next line of devices is gonna be even worse. So what do we have here? So -7 looks good. -5 is exactly where we were before. That looks somewhat over extruded. The -3 has definite signs of over extrusion. The -9 has a ridge there. They all can use a bit more squish. I mean, you can still make out the individual lines there, so we can definitely go a bit closer to the bed still. But that means that we can use our own PLA because it didn't make any difference. Let's discard this, and we can set this to 0.96. Well, let's 9.7 it. That looked kind of like the sweet spot in between. Oh, let me maybe take you along. So we're going 0.97-ish. That should be fine. And now on to the next test. First though, I wanted to test the extruder again, and for that I need my tape. Oh, and I see that the music is off again. Oh no, it's good. It's good. Never mind. Never mind. And we're going to... No, let's go front. Going to set this up as 70 millimeters again. Gonna add a little flag there. Let me check that that actually went the way I wanted it to. There, here's that side. Let's move that out by... Yeah, that's pretty much it. And we want to now maybe move that a bit out of the way here. Let's maybe not forget to add this in again. And then we want to heat our nozzle to 220. There we go. Oh. No, not that. Go away. Go away. I'm not sure why, but the Twitch stream on my end keeps hanging, and I'm kind of guessing that it has to do with the way that the monitoring computer is set up. But yeah, it's definitely funky. Yeah, you have fun. Have a nice night. Glad to hear you enjoyed it. And yeah, I'll catch you later. I'll still be around to do a couple of things here. Still want this to be printing at least somewhat decently. There we go. And yeah, that basketball, I kind of figured that you want to see that. It's kind of the thing to print right now, and usually I don't like to follow trends, but it is such an awesome gift for my godchild. He just has to have one. He really has to have one. Okay, and this looks quite decent. We pushed about not even a millimeter more than we bargained for, so it's not even 2%, not even 2% of an error. I think it's way less actually. So the E step is definitely correct. The E step is doing what it's supposed to. Ja, hallo. Hallo, muss ich noch mal gucken. Na komm. Na komm. Hoch. Hoch. Oh, hallo. Hi. There we are. Another visit from my boss. Richtig hoch. Los, komm richtig hoch. Du musst gekuschelt werden. Du musst gekuschelt werden. Richtig hoch. Na komm. Na komm. My boss just doesn't want cuddles at the moment. Du kannst hochkommen. Ja, du kannst. Du bist auf meinen Schoß. Ja. There we go. I got him after all. Oh. And now I'm getting kisses. There you go. See? Yeah. That is one funny dog. That is one funny dog. Yeah, so our E step is correct. We have a good extrusion multiplier. We yeah. What else? The question would now be, can we dial in pressure advance so these edges, these corners go away? And I'm kind of tempted to try. Yeah, let's. We're gonna build a tower. I don't like the line pattern, and the tower is just fine here. Let's see. And I don't like that that's so high, because I don't think we need all that. And we obviously don't want to waste any filament. I'm kind of assuming that we can get away with 0.5. Oh wait, I should actually click generate here. Let me show you what I'm doing right now. I'm currently configuring this, and I think we can get away with PA 0.5. Let's put it 0.6. Oh. Let's do that again. And it needs to be 0.06. Let's slice that and go. This is the first somewhat higher print, so I'm kind of looking forward to seeing how that prints. I'm not sure if we shouldn't instead do the Flowrate test first, because I kind of figure that actually let's do the Flowrate test first. Let's cancel this, and with cancel, yes, I use the e-stop, but I do want to know what the flow rate of this hardened is first, so I can make more informed decisions about the rest. Let's go. And yeah, I am printing this very, very tiny. Actually, I think I want a bit more detail on that. Yeah, that looks reasonable. So let's slice that, send that off to the printer. Let's see what happens. Let's see what the hardened in this thing can actually do. I'm going to tighten the extruder screw slightly to make sure it really grips. Should be fine still though. And then of course, while that's heating up, I'm going to set up the camera again. And there we go. Let's see what that does. I do need to grab something to drink though. That should do it. Wow, that sensorless homing is a bit rough at times. Not sure I like that. And I really need to get the panels on this printer. I really need to get the panels on there. Yeah. We'll see. We will see. What is the printer? What happened? Why are you there? Let's see what the console says here. Ooh. We have a move out of range. That's interesting. That's maybe something we should check here is probably move out of range. Yeah. And that looks like it's all the way in the back. Nice. This little printer is somewhat impressive. Oh, I didn't like that. I did not like that. What happened there? Oh, Oh no. Yeah, this sucks. These screws, I think they were meant to be 14 mil. They should be 12 because the hot end is hitting them, or at least the one. What we can do there is we can nah, I'll need to replace those. I'll need to replace those. That's no good. That is no good. That's not good at all. Yeah, there we go. Yeah, we'll need to use shorter screws there. That is definitely a given now. It's something we can't avoid. And let me see if I can do the stream monitoring better. And I know why we're having problems with the stream monitoring. Because its internet connection is not the internet connection it is supposed to be anymore. Yeah, fuck. Shit. So basically I am running the stream through my local network, and the stream monitoring is supposed to go through the network on an LTE router. So it does not impact the quality of the stream itself. That seems to work pretty well for YouTube. For Twitch, it seems to go good, okay, but for the stream itself on Twitch, for the monitoring itself on Twitch, I seem to be running into some issues. That should now be fixed. So let's hope that does it. I'm kind of surprised the LTE router lasted this long. I mean, it's 1:36, so we've been streaming for 6.5 hours already again. Yeah, let's see what we can make happen here. See if we can get this printing in any way. I think the problem here is the skirt. So what we can actually, let's cancel that. Let's restart firmware and restart this. And while we do that, we are going to enable support's fine, but we're gonna set these skirt loops to 0. What? And then we're gonna remove that and add it in again. Okay. And let's see what we can do here. That should be fun. I mean, Flowrate tests are always fun. I'm kind of hoping that we can get this one and the pressure advance test still done, so we have a good idea of what we're dealing with here. The retraction test I don't think we need to run. And VFA is not either, but those two tests I would still want to run. Then maybe print a calibration cube or Benchy. And by the way, yes, I realized that the print settings and print speeds I'm currently running at are still somewhat slow. But that is on purpose. That is very much on purpose because we want to like have all the mechanicals settled in before we do anything else. That kinda got me. But it is working. It is very close to the edge on one side, but it is working. And by the way, with this, you can actually see the inaccuracies to some extent of these sensorless systems. If you look at the at how far the left edge is out, it is almost at the edge. It is like there's literally no space left there to. You could maybe fit one other line there. Not much else, and on the other side there's about 5 millimeters. If we look at the same thing in the slicer, there we go. Same thing in the slicer, I said. It's supposed to be centered. It's supposed to be centered, and when we ran our homing test, where I tried to gauge the full range of motion earlier, you saw that it has a full range of 120 by 120 motion. So this, I would very much guess, is the inaccuracy of the sensorless homing. Let's move that a bit further out. Oh. I mean, how else would you explain that? So here's the question though. Why the hell is there space between the one side of the skirt and the other? Is it meant to be that way? I don't know. It seems weird. But hey, from a movement perspective, this printer is doing really well. we go. This seems kind of weird, to be honest. Let me check that slicer. I'm not sure what it's doing there in the first couple meters or centimeters. Ah, it looks like it got it. I don't get the problem with the pressure advance though, with the corners though. I mean, look at the sharp corners there. They're basically pieces missing. That's something I haven't seen before. What are retractions set at? Let's research it. Let's research it. I really don't know what those are. I mean, what the hell? We'll need to do the retractions next. This might have to do something with those. Has something to do with those. But I mean, they're not in the... I don't get it. I really don't get it. Let me see if I can get some answers here. Let's see if somebody on the Voron Discord knows immediately where they're from. They are too homogeneous and still too weirdly shaped to like the remaining walls look amazing, but those holes are just I don't know how to describe it, but it is just extremely ugly. Extremely ugly. It's good that this is done soon. That sensorless homing is kind of rough though. That is kind of rough though. Yeah, let's maybe look at a retractions test. And once we have a retractions test, just go print. By the way, this is why I like small printers. You just press print and it goes. There's no fuss about that. I do see some really ugly artifacts, so yeah, retractions definitely is something we need to look at here. Not retractions, pressure lens. But the walls themselves look kind of cool. I like that. We do have some fail in the flow, some artifacts in the flow though. And I'm kind of surprised to see that that it's that far up. Let me maybe take you along here. So if we look at this, this is the result of our Flowrate test, and you can not see anything because it isn't in focus. That should be better. If you look at the upper ridges here, you can see fails in flow. You can definitely see that there. You can also see artifacting here already, so that's even further down. If we look at other pieces, they look pretty okay. So except of course for these corners where I really have no freaking idea where that's coming from. I'm really not sure if this is supposed to be a flow fail already. Because for me, it looks like something else. It really looks like something else, so we'll need to see. Maybe we'll reprint it later when we figure that out. But for now, if I look at these artifacts here, and I want to basically see what my flow rate would be, I would estimate it somewhere below this first artifact here. So 13.8, 14-ish millimeters from the bottom. So if I remember, our settings were 1 millimeter per millimeter squared in flow rate. So that would mean we could almost do 22 millimeters squared in flow rate. That's cool. Oh, I'm not sure what I did there. It's definitely not the intention. But yeah, we'll try it out. We'll definitely try it out. If it says 22, I would probably go with something like 18 to be on the safe side. But yeah, that looks good. I need to rename these though, because I'm pretty sure the Trident can push this faster. This current setting is definitely only. Oh, and maybe let me take you with me here. I basically went in here and set the max wall flow rate that was previously set to 12. Set that to 18. I guess we can go 19. There you go. Let's push it a bit. And once we have the Dragon hot end in here, it's probably going to be faster. In the meantime, we still wanted to do a pressure advance test. And let me check if anybody answered me already on what our little artifacts here are. There we go. And this has the same problem here. It has this thing between. Anyways, retractions wise, I'll need to have a bit of a closer look here, but I don't think we actually need any. And by the way, this printed just fine. But I do think there's something wrong in the settings. We may need to update Clipper. We may need to update Clipper. Well, let's see what this print does. We're just gonna keep going, keep pushing until we get a passable answer, and we're gonna tackle the problem at hand. Yeah, but I think we need to update Clipper here at least. Oh, and let me, of course, give you the front row seat again. It's a good thing that these prints don't take too long. I think I have an idea of where the issues are coming from. Let's maybe check the config a bit closer. I mean, we basically relied on Fysetc to do this properly. I'm not sure that was a smart move. Yeah, pressure advance is set to 0.2 here. That may already be too much. But hey, at least it's working. And this actually looks good. This test seems to work way better. Oh, and this is probably why. This is probably why we are having problems. That explains so much. The reason why this explains so much is because this basically applies input shaper on axes with untested values to a printer that was freshly assembled and shouldn't be running input shaper in the first place yet, especially with the frequencies even in the 70s. And this, like, if you apply EI or MZV, sure, fine, but if you apply it in the wrong location, you can actually get increased problems. So why that was even in there, that shouldn't have been in there. That shouldn't have been in there. That is a complete fail, Fysetc. A freshly built printer should not have any input shaper value set. So this section should not have been enabled. No way. Yeah. So this seems to be working. I am glad, and let me just show you this very quick so you have an idea of what I'm talking about. These should not be on. These basically define vibrational values, and vibrational values really depend on how you build your printer. I am guessing that the way this printer behaves and vibrates is probably already majorly different from any other, because we used things like thread locker and wet and wild screws a lot, and religiously even, I would say. So there's probably other and likely reduced vibrations in this printer already. Yeah, and obviously if these if you leave these as they are, not gonna have a good time. The other one that we're currently trying to solve for, that also should not be on by default, because it, I think, might even end up being way too high as a value, is pressure advance here. That should also not be on by default. There may be a couple other things as well here. Let me maybe see which other features we can turn off, because to be honest, it looks like we have a bit of an issue here. Although this pressure advance build or print looks amazing. It looks really good. So I think pressure advance is one of the things that, if set up properly, will help us a lot here. The other one, just disabling input shaper, will also get us quite far. We're gonna print the flow test again, because there the problem was the most pronounced, and we can get away with only printing a couple of layers before we already see the problem. Yeah, but it's so, like, I mean, look at this. Let me see here if I can show you this while we also watch the print there. Look at this ridge. This is not stress deformed. This is deformed by the travel path of the nozzle. The whole thing here, the whole end piece is deformed by something not going right. And you could say, yeah, Paul, this is skipping, but it doesn't look like skipping. It looks like artifacts. Sorry, but it looks like artifacts. Yeah, well, we're gonna see if we can update a few things here. Surprisingly enough, the config here seems to be, let me take you along. Surprisingly enough, the config here seems to be reasonably up to date. I'm not sure when those versions were released, but it looks fine. But yeah, this seems good. This seems good. I'm amazed by the fact that the hot end seems to be able to push 18 to 19 millimeters squared of filament a second. Like, really, who would have thought? Oh, and by the way, that's also something we can check here. Do we maybe have a weird pressure advance value set somewhere here? Not sure where the pressure advance would be. But yeah, let's see. Let's see here. This is, by the way, how the printer is doing. So you can actually move you just a tiny bit further away before the camera loses grip. But yeah, that is definitely it. And it looks good. I mean, there's definitely something we can do here with pressure advance, and definitely it's by far not perfect. I mean, you can basically see the a few issues there on the wall, but it still looks good. And it's printing it in I'm pretty sure that there's potential here. And especially as a replacement, or like the even, I don't want to call it an emergency printer, but if you remember, we're building this so we can have a printer while we fiddle with the Trident. In case we break any of the parts on the Trident, we can reprint them on this. I think it's fine for that. I think it's gonna be especially fine for that. The only thing that still turns me off to quite a large extent is the fact that this printer is not designed with foam tape in mind, so that's something we'll need to add. But yeah, we'll make it work. We will make it work. Still need to add the foam tape on the bottom. Although on the bottom we have the feet, and the feet basically stabilize it from the other side, so I'm not too concerned about that. But on the back we definitely need to add it. We're gonna have to see if that interferes in any way with the way the spool holder mounts. It's gonna be interesting to see. But I would also expect 1mm foam tape to compress quite well. This, by the way, is a very, very exciting bag. I'm not sure what I'm supposed to think. I mean, yeah, sure. Risk of suffocation, definitely. But risk of cancer and reproductive harm? The hell? I'm not sure I even want to open that bag. I'm probably gonna see if I can find another, because that is scary as fuck. Well, I don't know. I don't know. But I'm glad that our multi-streaming at least somewhat works. I am not sure if it's fully working, based on the fact that both videos are sometimes hanging. The sad thing is that while I can actually check what the quality was like during the stream, once we concluded, I can do no such thing, I think, with Twitch, because for Twitch I don't think I have the setting enabled yet, at the very least. I'm not sure how. So, yeah. That is an interesting one. I'll have to find somehow figure that out. Or somebody needs to join the frickin' Twitch stream and tell me what the quality is like. But yeah, I'm kind of trying here. The numbers look pretty good, to be honest. At least for the primary stream. But I can't tell what the Twitch stream is doing. But I can't tell what the printer is doing, because it just finished its job. And we're gonna have a look at it. So, as a reminder, just as a small slight reminder, where was it? The pressure advance was set to 0.2 here. Now, if we look at our slicer settings here, oh, damn it. We had the end PA at 0.1 and 0.02 steps. Now, I'm gonna move you over to the details here. We're gonna give us a bit of room. Gonna make sure that this is as crisp as possible. And remember, 0.2 was the value that's set on the printer. .1 is up here. See this artifact here? See this thing here in front of the corner? Similar here. And here, and on every other corner as well. That is abnormal. Like you can basically see how pressure advance is just completely destroying these corners. So, what kind of pressure advance would I use on a printer like this? Like on a result like this? Let's look at it. So the whole thing, and let me maybe zoom you out a bit here so you can see it all. The whole thing is about 5-ish centimeters tall. Right? We said we wanted to go from 0.0 to 0.1 in 0.0 v0.2 steps. That gives us about 5 centimeters to work with. Now, the corner all the way here at the bottom 1.7 centimeters, 1.5, 1.6 centimeters have a very pronounced ridge before them. I'm not sure if you can see that in the stream, but there's definitely a pronounced artifact visible. And the upper, 1.6 centimeters, you start seeing the artifact. So I would actually go and take the value at about 2 centimeters high. Now, 2 of 5, that means that we're looking at 0.04. Is where the sweet spot is for this printer. 0.04. That is a far cry away from 0.2. That is so far outside of the the what we wanted to print. It's not even funny anymore. So what we're going to do now is we're going to remove that. We are going to grab ourselves another max Flowrate test just for shits and giggles. We are going to run this. Yeah, that's basically fine. We're going to discard the settings from before. It's going to generate our pattern here, and what we need to do now is we still need to add our 0.04 0.4 value. We already turned off input shaper. We're going to restart here. And yeah, we could go into more detail here to find the absolute best value. I mean, I think the absolute best value will be at 0.41, to be honest, and we have the resolution, so we can actually tell. Let's restart that. And let's print that again. And I'm kind of expecting that our problems here will now go away. They will likely go away now. I hope they will. Back here. And we're going to start our print. But yeah, that was crazy. That would explain a couple things. I will need to actually go on the Fysetc Discord and ask them what the hell. What was that? Did it have to be like that? Weird shit, I tell you, weird shit. Yeah, otherwise, let me have a closer look at print quality here. There's a definite pattern. And by the way, this is stuff you can also see on these, because they're so pronounced here in the move that out even further. So you can see what's going on with individual axes, like the X plus Y axis here, or the A plus B motor on this side, right? This is printed by the A and B motor working together. That looks fine. That looks actually really good, or at least pretty good. The 45-degree angle here, which is I'd have to check which axis that is, but either X or Y looks to have some artifacts, right? If you catch it in the right angle, you can see some artifacts in Z or Z of all places, right? They're patterns, they're strand patterns in Z that somewhat repeat. And anything else looks reasonably good. Okay. The sensorless homing just ran into the quote-unquote Endstop at such speed that the drop of filament at the bottom of the hard end was pushed off. Okay, so something weird happened here again, because obviously we forgot to modify our flow test by removing the skirt. There we go. We need to also apply these settings. Slice that again. Print that. Let's see what happens. Kind of curious if the problem is solved now, because to be honest, this looks good. This is passable. This looks like something that yeah, a usable printer would produce. And if this hard end or this tool head, it's not just the hard end that's determining the actual flow rate, right? It's the tool head as a whole. The hard end obviously having quite a large contribution, but the extruder is just as much responsible for properly pushing out that filament. But yeah, if that actually holds true, if this thing can really flow PLA at 19 millimeters cubed per second, I would be stoked. I might even leave it stock. No, not gone. I'm not gonna leave it stock. And by the way, if you notice the distance between the leftmost print and the rightmost print to their respective edges, this is again what I talked about earlier about the sensorless homing not being as precise, because if you look at them now they're pretty evenly distributed, and I can imagine that the next time we do the sensorless homing, we may get into a situation where it is, I don't know, further to the right. So on this printer, sensorless homing enabled, there seems to be an almost 5 millimeter swing on the Y homing position, the X homing position. And I can imagine that being the same case for the Y homing position as well. That is insane. I mean, sure, this build plate is large enough to handle this, but the hell? I mean, 5-ish centimeters, and I'm pretty sure we can get this 5-ish millimeters. I'm pretty sure we can get this lower, but yeah, it's still a lot. It is still a lot. Well, let's see. I'm kind of hoping that at least one of the issues is now solved. I can live with this sensorless working. I mean, we're not gonna print anything that major on this, I don't think. So yeah, let's just see. I'm also going to try something right now. I'm going to try to see if the stream on Twitch is actually stable if I don't have the stream on YouTube running. Yeah, that seems to work. Dang. Well, I guess nobody else saw the issue there or figured out what the problem there was. And look at that. That looks so good. Let's see if it actually solved the problem. I am so curious to see if this is working now. There we go. I think my microphone just cut out. I hope a couple minutes ago only, and not like any longer. But yeah, see, this is what happens if you actually use sane values. that config with input shaper already enabled and pressure advance dialed to such heights that it actually rips apart prints. I don't get it. I don't get it. It shouldn't be done this way. It's another thing that goes in the comment section for the printer. Well, again, I don't want to call it a review because I really don't want to do reviews. I just want to shout out my opinion, not thinking about completeness. There you go. Now you know. But yeah, what the hell? But I am tempted to print something useful. So, expecting that I will regret it. Oh, I know. I know what we're gonna print. Let's see here. So we don't need that anymore because obviously that's been solved, and really well, to be honest. There is another project I worked on recently. Is it this one? Skirt loops, no. The VFR, yes. Let's discard that. Yeah, that's only one plate, so no, that's not it. We still need to print a temp tower, I think. Well, actually, no. I think that should be fine here. I don't want to print a temp tower that's this large. I actually, if anything, I can see us printing one that's this high. 210 to 230. I mean, this is Polymaker PLA. So let's see here. What do they specify? .30 to 70 and 190 to 230 at 25 to 60. So I really wouldn't want to print PLA at anything below 210. I can see looking at 210, 220, 230. But I don't think it's worth looking at any lower. The problem with printing PLA or any any material at lower temperatures is the lower you go, the worse your layer adhesion gets, and especially with PLA, which is already quite brittle and tends to shatter anyways. It also cracking between layers is probably not something we want, so yeah, there we go. Yeah, and I guess this printer has its first 7 print hours on it. About another 30 to go, then we can run into a shaper and really let it loose. Yeah. I like it, I like it. Wow, and that finished. So we're just gonna do this real quick. We're gonna rip this off immediately and immediately start the next print so we can get this temperature tower done. Slice that, print that. We're not gonna play with the cameras before, but I am going to have a look here, and to be honest, I am astounded. I don't think this is, like, there must be something wrong. I must have done something wrong here, because this cannot be. The limit was set to 200 millimeters cubed per second, so the bottom looks fine. It has a good structure to it. It doesn't seem overly squished. The sides look like they look extremely good. Yeah, there's some artifacts. Okay, now we're talking. Some artifacts are to be had, but oh yeah, and here I see some signs of breakdown, but it's even fainter than the last time. I am amazed. I really am amazed. I think this printer, as it is, with the cartridge that's in there, the way we built it, might be pushing 24 millimeters a second of filament. Well, let's see here. Let's take that off. Why is our temp tower not printing? Oh, our temp tower is printing, but the say what? No, something went wrong here. Whoopsies. Something went wrong here. Stop. The hell? Oh yeah, that explains it. That would have been very bad. That would have got me a cloud of nasty. Because obviously, if you print any of these materials too hot, they will actually release gases that you do not want. So stay within spec. I'm gonna rip that off, and then, by the way, just for you to see what I'm doing here, I ripped off a layer of the filament path here. I will now measure the bottom layers, which are 0.5-ish, against the top layers to see how much thinner the top layers actually got. And yes, it is noticeable. So these are 0.41, 4.7, 6, 4.6, 4.8, 5.1. So there is definitely a difference. There's definitely some under extrusion going on. We're gonna measure this always from this side, right? So if we push this all the way together here with some reasonable force, that's almost 0.6. That there's a ridge though, so that's to be expected. We also need to account for any of the artifacts that are in the print here. But even at 2 millimeters high, we are already getting in a 0.48. So there's definitely a reduction here. But it still looks good. I mean, we could, if we're printing higher speeds, we could just adjust the flow rate accordingly. There's still a ridge that we need to take off, because otherwise that wouldn't work. Let's go front cam here. Also, I'm kind of wondering why our print's still not started, but I imagine it's because, yes, we need to restart the frickin' printer. Let's restart the firmware as well. Let's give it a sec. Reload. Yeah, and that takes a moment. There we go. Moment's over. No, we don't want one password. You're not gonna see my passwords. We want to print something. Anyways, we wanted to take off another chunk on this end. So snip in here, and then I can basically take the layer off right this way. The reason why I take so much off is because, yeah, we know that this hard end is capable of doing at least the first couple of layers, and this is just about the amount I would expect it to be able to at least do. We're measuring 0.48, 0.49 here as a thickness, and we're on the very top 4.0, so that's already like 20% less. So that's to be considered. So it is not exactly homogeneous, but even 2 millimeters in, we're already losing 10%, and then the rest of the way until the upper 2 millimeters, we're kind of fine there. So also looking at the artifacts I see here, I would still be fine with a 13 millimeter up. And 13 millimeters up is, let's look at it. Let's do some math. Oh, and let's check on the printer, because the printer needs to do printer things. And I think my control key is stuck, which now it isn't anymore. Nice. Yeah, we just had to wait for the bed to cool down. If it's too hot, Clipper will wait for it to cool down first. So that worked. Now we're getting to 220. And then it's going to print from the, it should actually print from 230 down, right? So I would expect it to change temperature here. And it did. Okay, so that's working. In the meantime, let's go here. Let's go to our max Flowrate test, and we're doing 8 to 24, so that's 16 steps in 1 millimeter per second. So our squared. So our test here is 16 plus a bit millimeters high. And we have 1, 2, 3, 4, 5, 6, 7, 8 steps here, the last 2. So let's say step 6 is fine. That's 12, which means that that would put us squarely at the 20 millimeter squared flow rate, giving us at most a 10% under extrusion. I'm gonna give you the print here again. So yeah. I am going to back this off to 18 based on that result. Although I'm only going to do that once this is done, because with these tests they usually change parameters, and I do not want to save one of those change parameters. By the way, the harder you can print them, the better. So in this case, if it turns out that we can print Polymaker PLA at 230, I'm going to frickin' print it at 230. Which reminds me, since we're not gonna print a plastic boat, but I do still want to print something useful here. Let's see what else in projects I had prepared. Flow PA, Red, MaxFR, and Temp. I can discard this now. And go down to 18 here. And if anybody is in chat and wants to see something printed, tell me. I'm not sure. I don't think anybody's here, but if you're interested, if you're there, tell me what I can print. I don't want to print the boat, but I am open to printing like, well, actually let's see here. By the way, this is kind of important. I don't think I explained this. The reason why in the other tests I went and changed the first filament to be the PLA, and why I'm now leaving it here and the way it is because I have these materials set up for me for different uses. Some of them I used on the RCF, so I want them to stay in this order, but these tests, the calibration tests, tend to use the first filament that's defined. So if you want to run these tests in PLA, the first filament here needs to be PLA. If you change that material, you're potentially causing issues with that test. So recommendation is when you're running these calibration tests, make sure the first material, if you have multiple defined, is your PLA, or is your target material. Right, now that we're done with that, we can just have the PLA here. That should be just fine. And this printer is so freaking fast. Even like, just to give you an idea of how incredibly fast this printer is. What was it? 1515? 1515 frame connector. I don't think we still have that here, right? I don't know, I don't see it. Let's remove it before it causes problems. These are all set to 13. So let's go to global here. And let's use 0.4, 180 infill. Oh yeah, we definitely want this at 0.2. We want the strength, sparse infill density. We can set to 40. What's it set to here? Say what? If we're building the honeycomb, I would definitely set that to 40. Speeds 30, 60, 30, 30, yeah, that's fine. And I am curious how long this plate would take. One hour, 41 minutes. That's a bit too long. And this, 4 hours, 4 minutes. Okay, that's also a bit too long. Let's look at this plate. Why does it take so long? 7 minutes travel, that's fine. 50 minutes inner walls, 36 minutes outer walls. Okay, okay, so yeah, no. Inner walls I can see us printing at 70, but outer walls I would still print at 30. Or we can print them at 40. There you go. Reslice that. 1/8. Yeah, I think we can print that on Monday while we look at our new project, if we manage to do that. So we're just going to conclude this, and then we can always have the printer with some kind of camera setup running while we do other things. I don't mind that, especially since this printer still needs to break in, since this printer still needs to yeah, do printery things, to stretch its belts, to get its feet wet. So after this print, I guess we're good. By the way, I am wondering, because we're looking to print this ball, and let's check out how long that would take. Yeah, let's check that out real quick. Let's see if there's a print-in-place basketball hoop. Well, not exactly. Not exactly. This is more like it, but this looks too small. I mean, I would need to print it on the Trident, because obviously the ball needs to go through the hoop, and if the ball is already as big as the printer can ever print, it's going to be a bit interesting, to say the least. But yeah, But yeah, we'll see. I am curious to see what the temp tower is going to look like though. We're already at the third one. At the bridging part, so this is now 220, which we have been printing with most of the day. And by the way, I'm pretty satisfied with the build sheet here. It grabbed onto our prints even when they were just very lightly pressed in. It does a very good job at giving the print structure. I'm very much interested in seeing how much of an elephant's foot we have right now because of the additional Z height adjustment. But all in all, I gotta tell you guys, it's looking good. It's looking good. Yeah, I do like it. I do like it. It's probably never gonna be the perfect printer, but it is definitely good enough to print functional parts. And as soon as we have input shaper running on here, the parts are going to look so good. The parts are going to look so good. And this, with the way this is currently working, this is a freaking fast printer. It's I was kind of expecting it to crap out at 10 to 12 millimeters per second cubed flow rate and give me trouble here, but really, this is working. This is working. I'm so happy. And it has CAD here. That's probably the reason. That's probably why like my Trident seems to be not well. Just don't get me wrong. The Trident is pretty awesome printer and it is working insanely reliably, but it does have its issues. It was not built with the same religious application of wet and wild. It was not built with the same care I applied to this one. So there's something to be said here about this printer actually having higher build quality, I would say. Probably something I should overthink when considering a Trident rebuild, although that's definitely not going to be anytime soon, I think. So yeah, definitely a consideration. You learn, and maybe somebody from LDO picks up the phone at some point, sends me one of their kits because I'm too stingy to buy them myself, and buy cheap ass Fysetc kits instead, and then build them up to become reasonably awesome printers. Yeah. Well, we'll have to see how that works out. But the fact is, printer went burr, and I'm happy. And this one is definitely doing a pretty good job. And note that we didn't have to wait for ages for this print bed to get to temperature. That's what I'm looking forward to most, because that is insane on the Trident. Trident needs about 20 minutes just to properly soak, so the prints don't come off the bed and they don't warp and everything else. And really, I know I could shorten that time, but I found it to be so reliable that if I really need to print something, I don't care, but it is impractical. Yeah, something we didn't talk about yet. The Annex K3 is coming. It is going to be in stock. I'm not sure if I already know, if I'm already mentioned it. It's going to be in stock mid of April, so end of April it will arrive here. I think we're just going to find smaller projects to do instead of jumping into the salad fork build, because the salad fork we can build whenever. We have a secondary printer now, but I do want a speed demon. I do want a speed demon and like all-wheel drive slice Magnum Plus hard end 48 volts. The works. It has to be done. It has to be done. There's so much fun to be had there. We need to get that started. So yeah, that's gonna happen. That's gonna happen. That, by the way, being the build that I have the most respect for, the most anxiety about, because if you look at the others, like even the salad fork has a decent manual. It has a very decent manual. It's no problems whatsoever. But I hear the K3 is a bit different. It's just a tiny bit different. We'll have to see. I'm definitely not going to skimp on that one. If it costs 1.5K, it costs 1.5K. Push comes to shove, we can build it and then sell it as parts that somehow got assembled. Oh, we'll see. We'll see. I'm just looking forward to the build and testing and seeing if we can make a printer that actually goes 1,000 or even 2,000 millimeters per second. And yeah, I know VZ bots can do some pretty insane speeds as well, but VZ bots are also so freaking big, and they don't have a 3-point bed leveling, and they I don't know. I like the prospect of having a 180 by 180 by 180 printer, likely with the mains bed, so it heats up in just about no time flat. The fastest hot end we can find with the all-wheel drive construction, and then the world's a better place. Well, I don't know, but at least we can then print insane speeds. Well, that looks like it's almost done. I'm not gonna do chapters today, so I'm gonna do those tomorrow. But I'm glad to see that this Twitch stream is running well. I'm assuming that the same is still true for the YouTube stream. Let's maybe stop Twitch and reload YouTube so we get to the current point and play that. Yeah, that looks good. That looks just fine. We're going to take this off and out the top, so we don't need to fiddle with the camera. Oh, these look good. Oh, these look good. Let me see if we can have a look at these together. There we go. Look at those. Look at those. Those just work. Let's rip them off. Let's rip off this skirt as well. There is no stringing anywhere. The overhangs, I would say, look best at the very bottom. There's still some artifacts here. Let me grab that. Like there's something I don't quite like, but I think it gets progressively worse the further up we go. Since there's no stringing, I might even be tempted to run this at higher, but we'll follow the specs. But it's good to know. So this material we're definitely going to print at 120, 130. The 110 layer adhesion is shit. 120 layer adhesion is 15 layer adhesion is shit. 120 is a bit better. 125 I really like, and 130 is just rock solid. So yeah, I mean, yeah, we're gonna, I mean, 130 failed pretty catastrophically, but anything below, wow. Yeah, look at that. And 130 is just reasonably solid. Let's look at the overhangs here. 130 overhang looks pretty good. Pretty straight. The 120 is fine. The not overhangs, the bridging. Yeah, those look all fine. Okay, 130 it is. There you go. 130 it is. Good. Good to know. I'm gonna take these off again. Do our setting and then go to frickin' bed. Yeah. And by the way, 15 hours of a print before we do input shaper. Oh, and this is going to take a while because this model is a pain. This model is just, you cannot imagine how much of a pain that model is. So yeah, let's just leave that and let's go into our PLA and let's just go set this to 130. There we go. 60-degree bed worked out fine. And we can definitely print 18 mil. That was the change we wanted to make from last time. So there. So there. That's it. 197. We said is the optimum here. It's a generic PLA. No, it's actually not because it's a Polymaker PLA. But who the fuck cares? Sorry, didn't mean to swear. I swear. And I guess that's it. And I guess that is it. That concludes it. I'm gonna put this in auto mode again and move that away since we're done printing. Yeah. We did it, we made it, we got it done. Here's the printer. Look at it, stare at it. I tell you, the cat ears are the thing. The cat ears are the thing that make it go. Like they're the only reason why this printer is working the way it does. You need the cat ears, believe me. There's no way you can have a well-performing printer without them. Oh, and by the way, I can actually take this printer and tilt it back. And apart from the filament spool falling off, I am not damaging the wiring, especially not the heated bed mains wiring. Isn't that fun? Isn't that nice? There you go. You guys have fun? Take care. See you potentially on Monday if I decide to start that series already, otherwise on Saturday. Make sure to like, share, subscribe. Remember, there's a Discord if you want to get in touch in any way. And yeah, Twittery things are there as well. So you guys have a nice night. or day or whatever else time it is for you. And in the meantime, yeah, thanks for playing.